Ladies and gentlemen, the next session will commence in 5 minutes. Ladies and gentlemen, the next session will commence in 5 minutes. Ladies and gentlemen, the next session will commence in 5 minutes. Ladies and gentlemen, please take your seats. The session is about to commence. Ladies and gentlemen, please take your seats. The session is about to commence. Ladies and gentlemen, please take your seats. The session is about to commence.
Distinguished guests, ladies and gentlemen, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the first day of the Sustainable Innovation Week Symposium 2024. As the Sustainability Innovation Week Symposium unfolds within COP16, the theme agriculture in arid environments emerges as a focal point for pioneering discussion on sustainable practice in water-scarce regions. This symposium brings together experts, policymakers, and innovators to explore cutting-edge solutions for enhancing agricultural resilience in arid climates. Through collaborative dialogues and innovative strategies, we aim to pave the way for sustainable agricultural innovation that harmonize food security, environmental conservation, and climate adaptation in arid environment. Join us in shaping a green, more sustainable future for agriculture at the forefront of COP16. Ladies and gentlemen, it's time to officially begin. Please join me welcoming our first speaker for the welcoming remarks, Dr. Mark Hall, the head of the Secretariat for the Saudi Agri-Food Tech Alliance.
Good morning, ladies and gentlemen. On behalf of the Saudi Agri-Food Tech Alliance, MIWA and RIDIA, it is my pleasure to welcome you to the first Sustainability Innovation Week Symposium. The symposium brings together national and international speakers committed to solving the Kingdom's most pressing challenges. From over 170 papers proposed to us, the rigorous selection process reduced us to the ones you will see over the next 3 days. We will hear about research and innovation in water security, sustainability, and food security, as well as the adoption and application of the latest technology innovations to address the theme of agriculture in arid environments. I trust you will all benefit from what you hear today and encourage you to engage with all the speakers to maximise the opportunities from this symposium. I will now hand you back to Abbas to introduce the first speakers. Thank you all for coming.
Thank you, Dr. Mark. Unlocking the Red Sea potential. Our next session dives into the blue economy. More specifically, how the Red Sea is becoming a hub of sustainable marine agriculture. From KAUST, please welcome Giulio Brizzi as he shares his insights into transformative technology shaping the Red Sea future.
Good morning, everyone. Thank you, Mr. Chairman. Today, I have a brief presentation on the technologies developed in KAUST to improve the sustainability of the aquaculture development expected into the Red Sea. I will go through this topic, so an overview of the aquaculture, what is the aquaculture sustainability, what MIWA has done so far through the aquaculture development program, and the step of reaching sustainability, so site selection, carrying capacity, bioeconomical modeling, and strategies for the future. First, a few words about aquaculture worldwide. Aquaculture has become, in the last 20 years, a very big industry. Has increased dramatically its production. Now we reach one figure of 175 million of tons of fish produced in the world. And when someone is going to the fish market, more than half of the fish on the bench are coming from aquaculture. That means that aquaculture has surpassed fishery. As you can see from the graph, fisheries has become more or less stable. The most part of stocks are overexploited, while aquaculture, both freshwater and saltwater aquaculture, are growing steeply. Aquaculture is even expected to double its production by 2050. Is a sector that employed more than 20 million of persons directly, and is considered one of the best way to reach the sustainable goals for United Nations. What aquaculture represents for Saudi Arabia? Well, first, one way to diversify the oil economy. Aquaculture in Red Sea has a very, very huge potential. Red Sea is a golden place for aquaculture because it's sheltered, has a good temperature, the renewal of water is intense, so it's a perfect place for aquaculture. Aquaculture can support economic growth, increasing the domestic product, can enhance the food security, because there is a huge production even now in Saudi, especially of shrimp, secondarily of fish. As the target also to increase the seafood consumption per capita in Saudi, now is very low, is around 8 kilograms per capita against the 20-25 in other countries, and can reduce the local production cost of shrimp and fish. At the moment, Saudi produce 110,000 metric ton of fish. The Vision 2030 strategy envisages one final production total between shrimp and fish of 530 tons, of which 2030 will be marine fish. So there is still room for growing, and the expansion will be dramatic in the next year. When we talk about sustainability, aquaculture as a way of producing food is one of the best way of fixing protein. We can consider aquaculture sustainable as far agriculture is sustainable. The feeds for aquaculture nowadays comes mainly from agricultural origin. At the beginning of aquaculture history, feeds were produced from fish meal and fish oil, so from fish capture. At the moment, it's not like that. The feeds are mainly composed by soja and byproducts of agricultural origin. The content of fish meal or fish oil in the modern feeds is minimal, is less than 10%. So we can consider aquaculture as a sister of agriculture. As global emission, freshwater and marine fish are much, much lower than swine and cattle. In terms of CO2 footprint, the figure is 10 times less compared to cattle. So to to build, let's say, 100 gram of edible protein, one cattle emit 14.8 grams of CO2. One fish, 1.5, so 10 times less. Aquaculture is also extremely efficient compared to other zootechnical industries. The figure you have here is for salmon, that has a feed conversion ratio of 1.1, means one salmon to grow 1 kilo needs 1.1 kilograms of feed, and build 61% of meat with excuse me, I don't see. Yes, 61% is the meat build, and with one protein retention very high, 31%, compared, for example, to cattle, where in percentage they build 10% of meat with a protein retention of just 15%. So the efficiency is extremely high. The Ministry of the MIWA has launched 8 years ago one ambitious program of development of aquaculture along the whole Red Sea. This to meet the goal of Strategy 2030 of 530,000 tons of aquaculture production by 2030. This through 3 main actions. The first, improving the formulation of feeds, addressing species-specific feeds, drawing new protocols for hatchery for new species, and addressing the topic of sustainable aquaculture. That was absolutely needed because the dramatic expansion expected. This was achieved thanks to the strong cooperation between the private sector. I recall here NAQUA, the National Aquaculture Group, SALIC, Tarawa Seas, NEOM, and the research and institutional partnership with MIWA, with KAUST, with the National Livestock Program, and the National Center of Wildlife. Let's go straight into the sustainable aquaculture. The aquaculture development must match with sustainability, because every industry has to be sustainable in time and have to be environmentally sustainable. Sustainability in this case is based on 3 pillars. One, environmental pillars, to preserve ecosystem function, to adapt the technology to the next climate change. An economic pillar to keep the business profitability. Aquaculture is an industry, so without profitability cannot live. And social, ensuring food security and safety, and establishing policies and goals in common with other activities. The first step to reach one aquaculture sustainability is the site selection. In general, our path to assess the sustainability use some models, but models are site-specific. So the first step for us is to point out the sites. What we did, we survey all the Red Sea, we took all the environmental parameters, we checked the marine communities, we checked the sea bottom. So we made an extensive work from Jizan to Umluj. All the areas that we consider suitable were classified in following 3 parameters: good, average, and poor. We calculated total area suitable for aquaculture in the Red Sea, and we point out the best areas for for aquaculture basing on an ecological, biological, and engineering criteria. We introduce also the wave and current in this evaluation. This is because this is the first step of aquaculture industry, because selecting a wrong site will impair the development of one industry for all the years in the future. We obtain more than 200 general maps of the Red Sea, where we have the ecological features, we have the marine traffic, we have the presence of coral reef, and so on. These areas were then classified using one algorithm we developed by our own, and classified in square of 500 meter by 500 meter as good, average, and poor for the aquaculture use. The second step is the use of predictive models. Predictive modeling is a technique to predict system behavior and outcomes. So we try to identify, basing on what we record, basing on the data we get from the past, we try to identify future risk, calculate the threshold for some parameter of interest, to predict the behavior under varying condition, and to forecast trends. In our case, we were looking for the evolution and the effect of fish farm effluents. We use a complex model, it's called Aqua Model. It's a model that integrates in itself a circulation submodel, a fish physiology submodel, a plankton submodel, and a benthos submodel. I will discuss shortly each one of these. The first is the hydrological submodel. This one is based on the oceanographic model that is running on the supercomputer in KAUST. Is a comprehensive climatic and oceanographic model. Takes its border condition from the VRF, that one is wrong, so from general circulation model, ingest data from satellite daily, give us the resolution of the current vectors at 1 kilometer, give us the motion field from surface to the bottom a step of 1 meter, 3 hourly, and is supported by a bathymetry taken from International Atlas or in some detailed areas from our own survey. This is how the model works. This one is one area, one full area, and we extract some part for our detailed modeling. The following model is a physiological model that we develop for each fish species of interest. So for barramundi, sea bream, sobaiti, seriola, grouper, and several other. We start from the feed composition, the ration, how much we feed the fish, the growth of the fish following ration and temperature, the species-specific physiology, so how much the fish growth, how much the fish answer to the energy input, how much is the basal and active metabolism of the fish, the excretion, and the egestion. So we know, following this model, when we feed 1 gram of this specific feed to the fish, how much is retained as nitrogen or phosphorus, and how much is excreted as nitrogen or dispersed as particulate matter. This is in function, of course, of the size of the fish, the temperature, the oxygen availability. Third submodel is a loop that keep together phytoplankton and zooplankton, starting from the availability of nitrogen originating from the farm. So the nitrogen is taken up by the phytoplankton that grows, in turn is grazed by the phytoplankton, grow by its side, and excrete again nitrogen that is in turn again uptaken by the phytoplankton. We tune this model existing for the temperate waters for the Red Sea condition that has a different kind of phytoplankton, a different irradiation, different basal condition for nutrients, and we obtain something that we consider likely to the reality. The last submodel is the depositional model. So when the feces of the fish enter the flux, they are deposited at the end on the bottom, where they enter one cycle of digestion or resuspension, and the digestion can be aerobic or anaerobic depending from the availability of oxygen at the surface and inside the sediment. So there is production of different compounds and different biogeochemical cycle in the sediment. This depending from temperature, sediment porosity, the amount of organic matter, the oxygen availability, and of course the bottom currents. When we have all our necessary data for input, so the physiology, the bottom type, the bathymetry, all the ambient parameters, because the model works with some basal data, basic data that are temperature, salinity, organic matter in the water, nutrients, irradiance, and so on, specific of the area that is modeled. The cage shape and position, flow field, feed type, and feed consumption. We obtain some spatial maps of effluents and deposition that are the basic for carrying capacity assessment. The carrying capacity is the maximum sustainable farm biomass that is not leading to impairing ecosystem function of fragile marine community at local and long-range scale. To be more clear, this one is one computational area of 5 by 5 kilometers close to some reef. I set up 4 farms of 4,000 tons. This is the kind of results we obtain. So the plume evolving in time following the variation of the current vectors. So we know where the plume is going, how much is resident. For example, the darker area is coral reefs. So we know if is touching from one side the coral reef or mangroves or whatever, and for how long remain the concentration higher than as that. They don't like me. Okay. So in this way, the model produces a lot of several outputs. So we know what is going on with nitrogen and oxygen, what is going on in the computational area, so some kilometer with the solid deposition and the fate of the solid deposition on the bottom, if the nitrogen trigger plankton blooms, and with the sensitivity analysis, so increasing, decreasing 10% each time the tonnage of each farm, we can reach one point where we consider that the effects are mild and can be sustained by the environment. Again, we have some spatial deposition of the particulate on the bottom, so this leading to a modification of biogeochemical cycles, so in some cases producing sulfides, that is considered one good marker of farm impact. And because the computational environment is a GIS, is a geographical information system, we can query some selected point. For example, the point, the black dot indicated in the larger picture. where we can follow the evolution of one of the parameter modeled in time. In the next picture, you can see for one area of interest the evolution in time of oxygen. So in this case, we understand that the oxygen goes below threshold. No, in some cases, even reaching very, very low values, even dangerous for the fish biomass. And it's clear that in this case, the organic load is too high, the biomass in farm is too high, so needs to be decreased, or the farm needs to be adjusted in that condition. Having set the system, we move to a regional assessment. So we set up in one much bigger area several farms, and we assess the potential of creating or triggering phytoplankton blooms. That is the parameter we consider more important on large areas. This one is just an exercise in one area northern of Jeddah, where I inputted several 4,000 ton each farms. So you see that there are blooms created by the nitrogen footprint, even at distance of several kilometers, but all these blooms are not persistent in time. So again, this method gives you the possibility of tuning the amount of fish production in one area, decreasing where the effects are more important, or increasing where the flow field, for example, is strong enough to dissolve the nutrients. The last step is to compare the ecological assessment with one bioeconomical modeling. So we theoretically build one farm with all its cost in time, how this cost is paid, how the biomass grows, what is the price at farm gate of the fish, which one are the revenue, making a sensitivity analysis oscillating the price. In this way, calculating the cash flow over several years. Who has practice on fish farming knows that cash flow is the main problem in fish farming. That is an activity that requires a large amount of fresh money each year to buy the raw material, and this money are replenished after some year when the cost decrease and when the revenues stabilize. Using this index, we calculate the investment return rate, and we tune the farm until we reach one level around 30%. 30% we consider that is one valuable farm. So we have these three instruments. So the siting, we select the best site. The carrying capacity, we adjust the capacity of the farms compared to the bioeconomical model. If one farm has low impact but is economically not viable, of course this cannot be run, so the farm must probably be moved in another area, or the species must be changed, or the production pattern, the production program must be changed as well. In this way, we can build one, let's say, ideal farm that we consider as one good hope to survive in the future, to have a long production cycle. We still miss some part. We need to collect some data on environmental footprint of the fingerling production process, assess how much is the footprint of raw materials in food process. Raw materials coming from Brazil has a bigger footprint than the one coming, for example, from Europe. How much is the footprint of a cage farm inside process, for example, building the farms, and also the footprint of fish processing and sales. This one is one exercise of a life cycle assessment that we still miss, and it's the next step we are going to entertain in the future. I think this one was my last slide. Thank you very much for your attention. Yes.
Thank you very much for the great presentation. Just a quick question. It's essentially a model where you can tailor it for other applications, not only for fish farming. Can you tailor the same model for assessing the waste on sea? If there is a place where there is a spillover or a lot of plastic waste, can you use the same model to follow the flow, the plumes and everything to detect if there is some types of waste there?
Thank you for the question. So the model, as I said, is a GIS, so a spatial model that is a bit simplified, for example, with respect of ArcGIS or QGIS, because it needs a lot of computational time. On the other side, replicate the images in time. So we have a GIS, one image of GIS, and further images of GIS, and so on, and we can replicate in time as much as we want. This model is widely used worldwide, for example, for tracking fish, for tracking sharks, for tracking turtles. This application for aquaculture is a plugin developed exclusively for aquaculture. The basic model is an oceanographic GIS, can be used for oil spill, because from a source, of course, can track the fate of any substance, provided that the equation of diffusion or of movement following the physical characteristic of the spill are satisfied. In the case of aquaculture, it works as using diffusion equation, so the nitrogen dissolved in water, or just takes the particles as solid entity up to the bottom. In case of oil spill, of course, there are other parameters to be taken in account: the density of the oil, its buoyancy, if it's on surface, is on the middle, and so on. But the model itself has the capability to track.
Any other question to our speaker? I think we are good to go.
Thank you.
Thank you very much. Thank you, Dr. Jolio, for sharing with us your insights. A greenhouse reimagined. Now, let us shift gears to agriculture. Imagine a future where greenhouses are not just sustainable, but also circular in design. To guide us through this innovation or innovative vision, we have Tim Tijsma from Van der Hoven. Please welcome to the floor.
Thank you for that introduction. So I'm going to be talking about the life cycle assessment of high-tech greenhouses, circular controlled environment agriculture. I'm working for Van der Hoeven, a design, build, and operator of high-tech greenhouses. We've been doing so since the 1950s, and we start with consulting, and recently we also operate. We've just opened a facility in the north of the country in Neom. It's a 5-hectare greenhouse, a research facility for growing tomatoes, lettuce, cucumber, and strawberries. Completely driven by seawater for cooling and using renewable energy. A second facility is on the way in close to Tabuk, will be opened shortly. When we're talking about sustainability, we always talk about our projects. So it's not a sustainability for the company per se. If we translate it to emissions, it would be scope 3 emissions. So really focusing on the greenhouse construction and the greenhouse operations. My colleague Fatima Marashi is the driving force behind this. She could not be here today, so I will be presenting. When we talk about high-tech greenhouses, what we mean is semi-closed or closed greenhouses, so greenhouses that are create an environment that is very much separated from the outdoor climate. So we try to make use of light, natural light, as much as possible. But other than that, we try to create an environment where we lose as little as possible. So we don't lose any water, we don't lose nutrients, we don't lose CO2. Keep ventilation to a minimum. We specifically don't go into the vertical farming space as it doesn't align with our view on sustainability, blocking out the natural sunlight in favor of a little bit of extra control. A similar amount of control we can achieve in a glass greenhouse. Now, what does that look like? It's vast areas of glass. Typical project is 5 to 20 hectares, all covered in glass. On the inside, there's almost no people. It's a completely automated system. What you see here is a lettuce greenhouse where all the lettuce is sown automatically on one side. It moves through over a conveyor through the greenhouse and is harvested automatically on the other side. A system like this produces 20,000 heads of lettuce a day from the moment that it starts harvesting. You can see that it's not growing into the ground. Everything is grown in gutters. So the water that's given to the plant is all regained and is given to the plant again. So all the nutrients are recycled, all the water is recycled. And you can see a bit of the automation system. So these are the gutters that move around the greenhouse. Climate control is happening separately. So these corridors are located on the sides of the greenhouse where air is cooled down, either evaporatively or mechanically. These fans you see, they connect to ducts. They distribute the air throughout the greenhouse. And so all the climate installations are in this corridor on the side of the greenhouse. Now, there's when we look at sustainability, it's often based on claims. So there's 10 to 20 times lower land use, 70, 90% lower water use, no pesticides, 0 fertilizer runoff. But there are always separate claims, and they never look at the full picture. So, for example, when you move crops from outdoor to indoor, then on all these claims, they work very well. But for example, on carbon, you start heating, you start using more materials, so you perform worse. So that's the question is, what does it do on the total? What is the more sustainable solution? Often it's focused on carbon footprint, as I said, very one-sided, especially for agriculture, where all these other factors have a huge influence. You can look at organic, but again, organic is based on, in many countries, is based on growing into the soil, which eliminates many of the benefits. Looking at fair trade, pesticide-free, all kinds of things, focusing on people, on pesticides, on land only. So we're looking for a more broader scope, for example, the eco-score based on LCA life cycle assessment. Basing that on 16 impact categories rather than just the 1 or 2. These impact categories are weighed according to a standard, so you can come to a single score for evaluation. Now, what's our goal in this? First is to see, are we on the right track with high tech? Is this the way forward to get a more sustainable food production? But also, how can we improve? So if it's the right way, what can we do to make it better? We need to identify hotspots, optimize resource efficiency, compare choices, everything we need to do to make our greenhouses future-proof. When it comes to life cycle assessment, we start with resources, production of the raw materials, manufacturing, distribution, use by the consumer, and then recycling or disposal of the materials. When we look at the greenhouse, the approach is slightly different. So we start with extraction of the raw materials and production of the equipment used. Then it is assembly, on-site construction, so the plot preparation, substructure, aluminium components, cladding materials, so everything that makes up the greenhouse. If we look to the operational phase, then for 15 years it uses electricity, water, heat, CO2, fertilizer. Young plants are brought in, growing media is brought in, and then at the end the product is packaged and is shipped. And this happens for 15 years. The greenhouse lasts for much longer. A typical greenhouse lasts for 30 years, but 15 years is chosen as an economical lifespan of most of the electrical systems, of the machinery. But many of them will last much longer. When we go back, then after the greenhouse operation, the greenhouse is disassembled and the materials are recycled. And we assume here that the greenhouse is disassembled, but there's an industry around reusing greenhouses. So after they're done for vegetable production, they're still fit for potted plants or a lower tech application. So it's a bit of a conservative approach. Now, we're using a third-party verified LCA tool. It's based on SimaPro. We use the fresh produce PEFCR. It's a first draft. It defines the rules to which the LCA should be set up. We see that it's still a bit too general. So it's based on fresh produce. A lot of it is produced outdoors, and that has different requirements. So we see some improvement, and we're also working with universities and other bodies to improve that, to get up to a PFCR that is specifically focused at greenhouse horticulture. Now, it uses the environmental footprint methodology from the EU, and data is coming from the EcoInvent database. And the reason for that is that the EF database is not yet available, as there's no official PFCR yet. As to functional units, first, when you look at the greenhouse, it's a 1 square meter of greenhouse with the boundaries cradle to grave. But at the end, we're more interested in what does the product do. So it's about 1 kilogram of lettuce. If you increase production per square meter, then you reduce the impact per kilogram of product produced. Here the boundaries are set a bit narrower. So it starts with cradle, but it ends at the gate of the distribution center. So after we deliver the product to supermarkets, to other retailers, it's out of our sight, so we cannot see what happens anymore. So that's where we stop in this analysis. The project is a fully automated lettuce greenhouse, 2.5 hectares. That's the project that has been assessed here. Mechanically cooled, fully electric, using liquid CO2. And what we see in the results, when we look at a single score of the greenhouse structure, we looked at all the different categories, all the different materials that we use. And the first thing that really stands out is the sandwich panel. So sandwich panel is used as insulation in the walls, but it's not something we particularly need. So it's not that we especially need per foam sandwich panel. We could use other types. So this is a very easy improvement, changing the installation material to a more sustainable type. Now, many of the other categories are related to the structure. Steel and aluminium, these are items that have been optimized over the years, mainly as a cost reduction. So in quantities, there's very little improvement to gain here. But in sourcing of the materials, there could be a huge improvement. So sourcing more sustainable steel, sourcing more sustainable aluminium. Same with the glass. The amount of glass reducing is very hard, but getting a sustainable producer or a producer that's closer to home is very doable. You can see that next to the glass here is transport, freight shipment. A large part of that is the glass, which is typically coming from China and is shipped for a long distance. Smaller items, PVC already contains 40% recycled PVC, but there's huge improvement to be made there. But for example, the concrete that is used on the floors, on the walkways, is a very easy replacement. We can replace that with sustainable alternatives. Same with the ground cover of polypropylene. Using a different material is relatively easy here. Now, when we look at the impact of the structure on the total life cycle, we can see that's actually quite a small part, greenhouse structure compared to the full operations. And if we look at the full, so our focus should be on improving this operational stage. It's not completely within our scope, but we have a huge impact on, huge influence on how the operation will work. If you look at the different categories and you see on the top, water use is very limited. Everything is already recycled. But if you look further down, then a fossil fuel use is a huge factor. Climate change is a huge factor. But for example, land use is again small, as expected. If we dive deeper into that operational stage, then you can see that a very big part is made out of energy. So the first category is energy. As expected, moving crops from outdoor to indoor improves on many factors, but not on energy, as you use energy for heating, for cooling, for the fans that you just saw. Now, there's many solutions for that. For example, at NEOM, it's fully electric and based on renewables, but there's also many ways to do that locally. An example in Japan, where the greenhouse is powered by a biomass facility. The biomass is used to produce power for the grid, and the waste heat from that is used to heat the greenhouse. And also the CO2 is captured and is used inside the greenhouse. Now, a different example in Kazakhstan, it's a big chimney, not the nicest example, but it's an area where it gets minus 40 in winter. Using the waste heat and CO2 from that power plant makes that we don't add any extra emissions by growing there. It's a very remote area, so in this case we change the efficiency of heat generation for food miles. So there's a bigger transport area, but there's tomatoes that are growing in this place. Tomatoes are easy to transport, energy is not. The last example, in Australia, fully focused on solar power, 23,000 mirrors, focusing on the central receiver tower to produce energy, heat, and to desalinate seawater. It's close to Spencer Gulf, around 6 kilometers away, where the seawater is piped in. Now, so the energy part we can tackle, but it's a very much project-to-project approach. So we cannot have a general approach. We really have to look at what is available in the area. If we look further, we can look at more general approaches. So a huge part is the packaging. It's not completely within our influence, but we can make big changes there. And what we see is that the packaging film has a huge influence. There's many biodegradable options available, so even at the same price. So it doesn't have to become more expensive. More surprisingly was the corrugated board, so the boxes where the lettuce is shipped in. To us, the idea was using paper, using cardboard is pretty sustainable already. But you can imagine that lettuce has a huge volume and very little weight. So if we produce 20,000 heads a day, we have a huge volume that has to be shipped. So it's an enormous amount of cardboard that's being used here. So that alternative should be found. And then transport. As I discussed earlier, the food miles, that's here. So this is the transport of the product. So it is not the biggest one, but it's still considerable. So it's something to consider, moving closer to the offtake, building greenhouses in places on the offtake. But you understand, as I understood earlier, that it's that balance. So on one side, you try to find a place where you need little resources to produce, or where energy is available. On the other side, you want to be close to your offtake markets. Now, and then when we look at the growing materials, then the carbon dioxide, the CO2 that's dosed to let the plants grow faster, still have a considerable impact. And then peat as a growing media, we're trying to eliminate that altogether. So peat is a limited resource, which is not really necessary. It's just to hold the seed and to give the plant some structure to form roots. There are alternatives that can be reused. and would be much better. If you look at the end, calcium nitrate, a fertilizer, and the water is not discharged, there's no liquid discharge, so we cannot reduce that. All of that is used in the crop. These are the biggest impact categories. So our main first targets. After that, we also move towards the a little bit less impactful full categories. But for us, this is a very good way to start and to see that we are on the right track with this high-tech horticulture, but still have improvements to make. So we're working very hard now on making those improvements and making our greenhouses more sustainable. Thank you.
Any question from our audience?
Thank you very much, Tim. It's a great analysis, but I notice it's restricted only for lettuce. And you know that we have the greenhouse crop #1 is tomato, pepper, bigger plant, higher plant, okay? Is one thing. And also in the greenhouse operation, the single score process, you put the energy first. But I haven't seen the water. So the sustainability pillars, energy and water, because in Saudi Arabia, I think we prioritize water before energy. Other question, please. What's the right sustainable size of each compartment in smart greenhouses? Because usually, traditionally, we have 5,000 square meter compartments in commercial project in KSA. So what's the right size and sustainable size for that? Thank you very much.
To your first question, we started out with lettuce. It's a huge market for us now, but we use that to set up our methodology, and we're going to expand it to other crops. So tomato is a very good second one. Peppers, cucumbers are third and fourth. If we look at water, it's always a trade-off. So you use more energy or you start using more water. Typically, it's very hard to reduce both of them. In this case, we use desalinated seawater, so the impact there is not so big. Then the impact of the water is, again, energy, because you need that to desalinate. If you don't do that, if you get well water, then of course the water will be a much bigger category, definitely. And the last question is, a typical size for us is 20,000 to 50,000 square meter, so around 10 times the size as you mentioned.
Okay, you mentioned that you are using the seawater for cooling. Do you desalinate the seawater for cooling, or you store it as a raw seawater?
We use it for evaporative cooling, and then we use the raw seawater. For desalination, for irrigation, we first have to desalinate it.
Thank you so much. Very impressive work. My name is Ali Abu Saba, Director General of the ICARDA, International Center for Agriculture Research. Two questions. One, on the cost. It would be good if you could give an indication of what is the current cost per head currently, and what would be your long-term objective in terms of bringing the costs down. My second point is whether you have tried to cool the water at the root zone to partially compensate for an increased cooling within the environment. We've done some research in this space, and we've been able to demonstrate that cooling at the root zone could effectively bring similar levels of production, but with corresponding significant drop in the cooling of the environment. So there's one additional thing to experiment with. Thank you. Otherwise, very exciting, very futuristic. Thank you.
Thank you. Yeah, the cost, they vary a lot. From a simple greenhouse in a place that has a favorable climate, for example, the two that we're building now, if you build it in Tabuk or you build it here close to Riyadh in the nearby agricultural area, you need a lower technology level than we would build on the Red Sea coast, for example. Crops are usually different, also the level of automation. So I'm happy to discuss this afterwards with you. Your second question, the root zone cooling. For these lettuce greenhouses, we cool the irrigation water. So the lettuce grows in these gutters, and the water flows through. It only takes up a very small part of that, and that water is cooled. Yeah, partly also to get enough oxygen to the roots. Okay. Anyone else? That's it. And thank you very much.
Thank you, Tim. CubeSat for sustainability. From the skies to the field, our next speaker explore how cutting-edge CubeSat technology is revolutionizing environmental monitoring in Saudi Arabia. Please welcome Faris Al-Malki from Tate University to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everybody. It's almost there. My name is Dr. Faris Al-Malki from Taif University. I'm an associate professor in aerospace communication engineering, as well as I'm a professor visitor at Oxford University and Brunel University in London. I'm here today to take you at altitude of 400 kilometers to explore the potential of using CubeSat, which is a nano satellite or small satellites that can deliver various applications. Before diving to the agenda, I would like to explain why we are interested to talk about this kind of initiatives in Taif University. Taif, if you all know Taif, or you may visit Taif anytime soon, it's located near Mecca, which is the holy city. It has two miqat, ihram, so they can visit Mecca through this city, as well as it's a tourist city. So it targets 3 million visitors every year, and this figure can be doubled by 2030. So they are interested and curious actually to develop various environmental initiatives, including, of course, increasing the plants in terms of fruits, as well as flowers, as they can call it, a city of flower. It produces 5 million roses every year. I think this is a good start about Taif. 17 SDGs. It's all we all here to help and promote things regarding 17 SDGs, Saudi initiatives 2030, aligned with many initiatives and goals to deliver and target this initiative. Of course, Saudi Green Initiative, one of the most important one that we are excited. Myself, I'm working on projects that can meet this target, which is 10 billion trees, one of the main targets. Of course, digital transformation. When we talk about Saudi initiative, it's 3 pillars, 10 programs, and 97 goals. 30% of these goals target digital transformation. So we are driving by very important part in terms of the digital transformation, as well as the fourth industrial revolution, which is the main impact that we need to focus on. I put this slide because farming cycle is very important part here in Saudi, specifically in Taif, Al-Baha, Abha, all of these cities, Tabuk, of course, Al-Qasim, Haid. It's almost everywhere in Saudi. So we have 3 main pillars, either all the logical pillars, physical and technical pillars. To integrate these pillars, we can achieve the goal that we need to target. Of course, the fourth industrial revolution has various applications and various pillars, including the AI, Internet of Things, UAVs and drones, space communication or space-based communication like CubeSats and satellites, of course, big data and cloud computing. All of these pillars can integrate well with the CubeSat and nanosatellites. It can deliver and promise to bridge any gaps can happen with traditional means. What I mean by traditional means is a traditional and ground base stations or a monitoring from the ground. So as we call it, an eye in the sky. It can cover and it can provide an aerial imaging, including, of course, the environmental parameters. Various applications CubeSats can deliver in terms of science, in terms of environment, in terms also of exploring the space, although it's very promising aspect of space communication, but it's still evolving and growing day after day. Our aim here in this project, this is one of the initiatives that I worked with various colleagues here in Saudi Arabia, as well as the UK, Oxford University, Brunel University in London. We tried to promote and to develop an intelligent CubeSat to monitor various various parameters in the environment, including oil spill, counting the trees, as well as monitor the green spaces in Saudi Arabia. We have these objectives in terms of defining the parameters. What are the parameters? We need to set a benchmark for that. We try to develop the AI and the artificial intelligence algorithm, because we can use an existing one, yes, of course, but we need to add on that. We need to evolve and we need to develop that further and further. Simulation part, within some time, the lack of resources in some university and labs locally, we need to collaborate with nearby university. I'm collaborating with some colleagues at KAUST University. Prototyping, we try to prototype something locally with the help of postgrad students, master students, to build the knowledge at the university with the help of various departments, physics, science, of course, computer engineering and engineering department, electrical engineering as well. And then we need to analyze, and we can talk about the further improvement. The action research, AR, methodology that we considered in terms of planning, acting, and then we can observing, reflecting, return back to the main point, improve the parameters time every time. So as academic, I tend to use this kind of action research methodology. It helps me a lot to speed up the algorithms, the development quite rapidly, actually. The literature review that we covered in our studies, it reached around 180, 190, I cannot call the number, but I tried to summarize it in three main families. I will call the first family satellites, the normal satellites, the massive one, which cost a lot of money. It has its own, of course, advantages in terms of footprints, the lifespan, etc. But it has some issues, of course, related to cost and some existing technology like blockchain, etc. UAV, my favorite one. Every time I see a drone, I say, oh, this is my son, this is my daughter. I love drones because it's rapid deployment, cost effective. It has its own advantages, of course. I use that many times in many applications in Taif and elsewhere as well. Ground station is not my favorite one because it's vulnerable to many issues, as well as the limited coverage, interference, noise, many issues. CubeSat, it can bridge and it can sit and fall between this normal satellite and UAV. So it's a middle solution with its own advantages. So our proposed system tried to add some values to increase the parameters that we need to monitor. Second, a blockchain. You might ask, why I have to use blockchain? isn't necessarily to use blockchain to secure data from satellite to space. Yes, it's a food security. It's information that government entities need to protect. So the good thing about CubeSats, you can have your own satellite. Whereas with normal big satellites, you may rely and collaborate with other nationalities or collaboration with other entities. This figure shows the main 4 parameters that we need to target. First, water detection. Watershed only. Watershed also. So in Taif and other cities, you expect water happening at different places, but using this kind of technology, you can get more knowledge about the spaces and the places that might collect water there, so you can find better resources there. Tree counting and vegetation assessment. Tree countings, we target 10 billion tree by, according to the Saudi Green Initiative, so we can help on that. In Taif, we plant 1,000 trees a day at one of the initiatives. So I thought, okay, I need to check these numbers. Either I can rely on sensors, ground sensors, or I can do that remotely using the drone or even the CubeSat. So we can do that. Vegetation is assessment. We can assess the green open areas with the right parameter like NDVI and other parameters. Oil spill, we don't have sea in Taif, of course, but we have Jeddah and we have the Red Sea nearby. Oil spill detection is a big topic. CAO's doing very great job with this one. That's why I'm collaborating with my colleague there to do further research and further collaboration in terms of oil spill detection. And we participated in few events in the last months regarding the oil spill only. Blockchain doing the same, how we can protect the data from space to the ground station using the blockchain algorithm. We developed one of the existing algorithms. We developed that and reduced the complexity and the power consumption of the algorithms. And this is our proposed system. If we need to block that, do it in a block diagram that shows the link budget parameter, how we can do the connectivity from the space to the ground station, how we can assume and make sure the connectivity getting the lowest path loss in terms of distance, 400 kilometers above the ground. So it's very important part to use something like artificial neural network or any deep learning techniques to develop the connectivity. And this is the first part. And then water detection, tree vegetation assessment. We put that in a deep learning technique using YOLO 9, and we developed that existing model. We didn't do it from scratch. It's already there, but we tried to develop that. And then we can get more precise or near accurate, high accurate data from the space using blockchain to protect the data, and then we can get the output out of that. Of course, the oil spill can join the party. This is the simulation part. First of all, before doing and diving to the experimental one, which is going to cost a lot, so we need to use the simulation links, simulation toolbox to predict the results, to get an initial results that help us to build our final prototype. I have 5 minutes more. Okay, this is the main points regarding the design. We use MIMO antenna, which is a multiple input, multiple output antennas. We built that using the CST Microwave Studio Lab. So we try to use this one because we need to ensure directivity, we need to ensure diversity, high accuracy, high data rate. So that's why we use this MIMO antenna, and that's one of the main contributions, as well as the, of course, developing the algorithm regarding YOLO. To launch satellites, we need to speak to the Saudi Space Agency. We have to speak to Elon Musk. Yes? So we need to think about that. Beforehand, we can consider something at a low cost. So we use a tethered balloon, which is at altitude of 100, 200, up to 500, depends on the regulation in your city. And then we can use that to test our prototype. And that's what we have done in Taif. So we use a tethered balloon, which is a helium-filled, solar-powered airship. And it helped to take the of course, the CubeSat to the space. Of course, there is something regarding the orbiting, the movement of the satellites. We consider that part of our simulation parts. Machine learning and the deep learning tasks, that's the main one. Water detection, tree, leaf monitoring. So we can check at Taif, Jof, Tabuk, of course, it's well known with the olives. So we try to use one of the leaves of olives to check the any issues it might appear with this kind of trees. For example, grapes in Taif, of course, it's well known. I'm promoting Taif a lot, yeah? Is that true? Yeah. And this is the initial results using the leaf detection. As you can see, a different tree. I will show you now a video. The one in the middle, tree counting and checking the trees from one of the local farms in Taif. Rose farms, of course, in Taif, NDVI of aerial imaging. That's the initial result. Also, we use and we rely on Internet of Things to detect and measure the what we call the water and the soil moisture for these parameters to check if we need to save more water or we need to put more water for these plants. So we get good results in terms of that using Blind dashboard. And that's the initial results for NDVI, link budget parameter, object detection, and the iteration, number of iteration, a blockchain, performance, all of these results. And by the way, this is one of the papers that already accepted and under publication at Oxford University. Inshallah, you're going to find it soon. And this is the prototype. That's the very early one. It's made of in Taif, or we built that in Taif. So we tried to build it with our own existing resources, and then we moved to the best prototypes. We tried just to find out the initial results for that. And this, the tree detection and vegetation monitoring from area space as the CubeSat's moving. I have 1 minute left. That's the conclusion. That's the CubeSat promised to deliver various applications to have more panoramic benefits. Of course, coupling these kind of technologies with CubeSat can bring many advantages and added value for that. We work more on environmental monitoring. At the moment, we try to consider UUVs, which is unmanned underwater vehicles, to explore the space and oceans for farming, for various applications. I'm working on that. Of course, from space to deep ocean, it's another story. Hopefully, we can share that, inshallah, next year. And that's it. This some of the selected references. Inshallah, you're going to find this paper at Oxford University Press Journal at any time soon, inshallah, next month. And this is the contact details. I'm happy to answer any question you may have. Thank you very much.
Thank you, Dr. Fares. Any question?
Assalamu alaikum. Thank you very much for this informative presentation. Actually, I have some concerns about the CubeSat specs, such as the type of sensors and how many sensors in the CubeSat, and the special resolution of the results of the output of the CubeSat. Thank you.
Thank you. In terms of the remote sensing, it's mature enough to be tested and validated. It's already there. And we use that for various applications, even to explore things under the ground, for mining, for mining detection, and etc. So based on the secondary data we analyze, it's already there. We use that for environmental application. We set only our parameters, our threshold to test that, using the secondary data to predict, and then our primary data at various altitude. What I'm concerned myself is the orbiting, because the CubeSat can move and to return to the same point within 90 minutes. It needs 90 minutes to be on the same spot again. So this, we can call it, this shift and movement should be replaced by another CubeSat. So you need a constellation of CubeSats, not only one CubeSat. That's my own concern actually at the moment, but that's the nature of this kind of technology. What we can do is collaborate and integrate, if I may say, with UAVs and normal satellites. So we can call heterogeneous network: satellites, CubeSats, UAVs. And then you can have a full picture of the environmental monitoring, of course.
Thank you. One last question, please.
I can't hear you, sir.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you very much for your presentation. Can you please elaborate more about the power management, power requirement for the CubeSat?
Yeah, sure. In terms of the power, we use the solar panels, and that's for initial prediction. For that, we use up to 12 ampere for that. I know it's not enough for orbiting. That's why you need more and efficient solar panels with a high cost. So we use a medium or a simple solar panels to test the aspect. What I can elaborate more, to use more turbines on that. So we can use the wind turbines as well as the solar panels. I know it needs different switch to move or to transfer or change the power, to have like a power bank for each one, because different current, different voltage, and then you can supply that to the CubeSat or to any system. But that need to, you have a trade-off here in terms of the weight. If you can think about adding many things, add many payloads, you have to think about the weight, of course. Thanks.
Thank you, Dr. Fares. Now I would like to invite Dr. Mark Hall to distribute the certificate for our first 3 speakers. Could you please come to the stage? Dr. Jolio from CAUS, please come to the stage. Thank you. Mr. Tim Tysma. Dr. Fares Al-Malki from Taif University. Thank you, Dr. Mark. That wraps up the morning session. Now it's time to grab a bite, meet your fellow attendees, and recharging for an exciting afternoon. We will resume, so don't wander too far, please. Thank you very much.
Ladies and gentlemen, the next session will commence in 5 minutes. Ladies and gentlemen, the next session will commence in 5 minutes. Ladies and gentlemen, please take your seats. The session is about to commence.
Welcome back. Let us dive into our next session. Water is the lifeblood of agriculture, and Internet of Things technology is helping us managing it smarter than ever. Here to share these innovations is Dr. Thamer Al-Khamis from King Fahd University. Please welcome to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. I'm pleased to having you in the scientific symposium. I'm Thamur Khamis. I'll walk you through one of the promising projects that my colleague and I work on, which is IoT to optimize the water management in agriculture. So before we do so, I have one critical question. What is Internet of Things? I know a lot of technology is evolving in different fields and sectors, but which comes first? So IoT is basically, I would say, a device communicating with other devices. And similarly, we have another communication or protocol, I would say, Internet of People, where people communicate to deliver different messages, data, sharing information, sharing experience, and so on. So when it comes to the agriculture application, we need to see how machine-to-machine communication, or sharing information, and that's one of the critical aspects that we focused on. As you can see on the screen, we have cameras. Cameras are deployed to detect and monitor 24 hours during the week to make sure we are delivering the amount of the water at the same level of the plants. On the other hand, we have the Wi-Fi connection, where we need to secure the data communication from machine to machine or device to device. And that's one example of many applications in IoT. Before we do and drill down to the case study that we developed, let's understand first the role of IoT in the big four technologies. I know AI is leveraging every aspect from academia, industrial, and so on. But when we look at the Internet of Things from a different angle, we can see it's on the top of these four technologies, I would say big technologies, coming from big data, data analytic, as well as cloud infrastructure and other technologies. So that's also give us a privilege to rely and deep dive into the application of Internet of Things. Also, in a critical point, we need to understand that IoT and other technologies are meeting our SDGs. The 17th, or I would say the 17th goals that we need to sustain, not only meeting, but we need also to sustain for future generation and make sure that they are directly connected with our missions and visions to achieve the sustainable future for our next generation. Here is the case study that we developed at KPPM's labs. We looked at the most critical parameters when it comes to comparing garden to a garden or farm to a farm and so on. We look at the temperature parameter, humidity, and definitely other parameters from tank monitoring or water consumption and electricity bills. We need to optimize these. And we looked at how we can develop that and how we can leverage these in different scenarios. We selected, I would say, two sensors when it comes to the humidity and temperature. We examined these two parameters on certain plants, for example, strawberry, apples, and other as well fruits. So we integrated with a cloud platform, which is the Blink, as it's like a third party to exchange your data and encrypt it in one cloud platform. And then also we developed the hardware, where the hardware consists of sensors, the midware with the controllers that can also deploy or apply with our algorithm. Also the logic behind it. When the pump gonna work, or maybe when the water usage should be decreased because we need to meet our, for example, pill consumption. Because power consumption is related to as well, integrated to the water usage. We need to optimize that in somehow to make sure we deliver optimized water usage. So you can see here we can monitor the water, or the full process from feeding the plant with the water, watering the plant, and then monitoring for a full week, or I would say a full year. We can only look at our phones from one click to a lot of cascaded, I would say, actions and the plans. So that's the typical case study that we developed, and we ensured that 8% to 85% water usage is decreased to make sure we meet as well as meet our electricity consumption. One of the challenges that we also encountered during development is that the communication technologies, which protocol we should go with, which I would say communication channel will be the suitable solution or the right fit for our application. You know, Wi-Fi is challenging in terms of not well equipped infrastructure, because Wi-Fi need a lot of investment to make sure either through servers and other hardware. Bluetooth is somewhat lacks at the ranges. Zigbee and LoRa is still under development, which is not our scope. So we'll selected the Wi-Fi to make sure we are on the right track to develop to next stage or the next expansion. And you can see this is one of the critical protocol, which is the 802 IEEE protocols, is that encrypted, and we can rely on it for future expansion. You may wonder, okay, what we can also see behind the deploying the IoT. What's the potential of using it? Is it worth to go with, or it's just a technology to use? As we did the experimental and we looked at the top benefits that we interested in, we observed we can optimize the water usage from 80 to 85 in the decreasing the water consumption, which is meeting our local initiatives as well as Middle East initiative for a greener economy. For the environmental sustainability, we saw a huge interaction or direct connection with the SDGs. IoT helping us in achieving that in faster way and safer way, because we need to sustain our water usage as well as meeting our pills consumption. Reducing the water operational cost. When I'm speaking about operational cost, we are speaking about things like indirect cost, direct cost, maintenance, and other parameters. While deploying IoT, we can see the operational cost curve is decreasing dramatically, where that's meeting our interest to deploy the right technology in the right place. I know farmer owner look at the productivity of their farm, how we can also rely on that. IoT is making sure and guarantee the improved crop yields when, for example, now in Saudi we're famous for dates and other products. We can make sure that meeting our KPIs and our vision and mission as well during the deploying the Internet of Things and other parameters. That's the four of them. But don't forget about protecting your privacy, data privacy. Because as far as we protect our land for our future, we need also to tie in the privacy of our data. This is the most critical part where we looked at the sensor layer from deploying the devices, the edge devices, from hardware to software. And then we looked at the communication network where we talk about machine to a machine, or where sensor is talking about to another sensor. That's also, we need to encrypt it. Integration. I know hardware is not talking to software. We need to make sure we are having a reliable and redundant, I would say, data gateway, so we can shift between these. Analysis, IoT provides you the data to deploy to further application, either prediction, deep learning to further rely on the data for future data, decision maker. I mean, if you are a decision maker, IoT will give you the solid, I would say, foundation of the data to look at it, see what's the trends, see what you can leverage, and what you can also, use or not to use. This is the last layer where you can act. But when it comes also the opportunities where we need to look at the IoT in different angles. I mean, coming from edge computing, we need that data to make sure our algorithm in the next expansion is well fit, or reliable to link to other applications. For example, we are looking here at the water usage, but if you are interested to look about the motor's prediction, is the motor gonna, or the pump gonna, for example, fail at some certain scenarios because your garden or your farm needs high water consumption. That's one case, but when you look at about the standard and security for making sure we are tightening up the right information or the right protocols for our application. That ends our presentation. Thank you so much for joining us, and feel free, please, to ask and interact.
Any question from our audience?
Assalamu alaikum. So from the network connectivity, you said you use Wi-Fi. Have you looked at like something more of a long range, low energy, which is like LoRa?
Yes, we looked at some cases, but as of now, we are not authorized to use LoRa in terms of different frequencies. So that's another, I would say, discussion on selecting the right wireless connection. But now we are using the Wi-Fi to see what kind of challenges that we observe as we go on. Later, when we get the authorization to go further and it's okay to use it, yeah, we are happy to deploy it anytime.
Any other question? Thank you, Dr. Tamer, for the presentation. Sustainable water strategies. Our next speaker are tackling one of the kingdom's most pressing challenge, sustainable water management. Representing cows, let us welcome Dr. Farouk Taher to present their groundbreaking cows water model. Please welcome to the stage.
Assalamu alaikum everyone. My name is Furqan Tahir and I'm a postdoc fellow at Urban Lab Cost. And today I'm going to share some insights regarding the cost water model that we are developing. So why it is needed and why it is important. So being the water critical infrastructure in Saudi, we have three main, you can say, water consumption areas: industry, urban, and agriculture. For most of the agriculture needs are met by underground water, which is depleting. And for the industry and urban, most of the water needs are met by desalination. So underground water is depleting, and for desalination, it's energy intensive. It has higher carbon footprints. Also, in order to make the desalination plant, it has higher investment. But with respect to time, we have other problems: urbanization, population growth, industrial growth, water depletion, and these all factors are going to put a strain on the desalination market. And we need to install more desalination plants. But the thing is, if we want to decarbonize the water industry, what are the routes and how we are going to assess the carbon emissions? So one way is to utilize the emission factors. So we have electricity and steam, and we just multiply the amount by their respective emission factors to get the total carbon emissions. But what about the other things: chemicals, raw materials, usage, transportation of goods, transportation of water from one city to another city? For this purpose, we have life cycle thinking, in which all of the stages from raw material extraction, manufacturing, transportation is included. And not only we get the carbon footprints at climate change, but we get other environmental impacts as like acidification, eutrophication, ozone depletion, human health damage, and other environmental impacts. Also, life cycle thinking, it helps us to identify the hot spots within the particular process. So we can look after it, optimize it to reduce the overall impacts. So if we apply the life cycle thinking to some of the water resources in Saudi, so we can see that like for each meter cube of water production, for desalination, it emits 10.4 kilogram of CO2 equivalent. The treated wastewater is around 1.24 kilogram of CO2 equivalent, and for the groundwater it's 0.36. So groundwater has the lowest, but again we have the water scarcity issues, and desalination is around 20 times or maybe more than the groundwater. Also, these desalination plants are coupled with the electricity and heat sources. So if we apply life cycle thinking to the electricity production from different sources, we see that if we produce 1 kilowatt hour of electricity from furnace oil, it's 1.03 kilogram of CO2. From natural gas, it's 0.475, and from solar PV, it's 0.019. So you can see that if you want to decarbonize the water sector, we need to decarbonize the electricity grid also in the national grid in Saudi. So in the water, what kind of stages are there which participates in the carbon emissions? So we have an example from water supply from Jubail to Riyadh, because Riyadh doesn't lie at the coastal area. So we have a plant at Jubail. It supplies water by the 412 kilometer pipelines. So we need energy to transport that water to the Riyadh city. Within the Riyadh city, we have a distribution losses which accounts from 25% to 40%. So for example, if we want 1 meter cube at the Riyadh household, we need to supply 1.3 or 1.4 meter cube from the plant. So that increases the carbon footprints by 30 or 40% just by the distribution losses. And then from the household, we have the wastewater treatment plant to check the overall water cycle footprints. If we calculate those emissions, we have two examples, one from RO and one from multi-stage flash. And you can see that like for desalination, it's only 4.72 kilogram of CO2 from RO for 1 meter cube. And for MSF, it requires more energy, it's 13.6. For the transportation, we have 2 kilogram, and for the distribution, it's 1.7 and 3.92. At the end, the overall carbon footprints are more than the 50% of the desalinated water. Why? Because of the transportation and distribution. So in order to calculate accurately those carbon footprints, we have developed the Kaus water model, in which we have the hierarchy for power generation, raw materials, anti-scalants, antifoulants, and what kind of a desalination mix we have in the system. And then we have underground water, and it goes to which sector, like built environment, agriculture, industries, and then we have wastewater treatment. So it calculates the overall environmental impact for across each sector. So the key stages to accomplish that Kaus water model is, first we will carry out the desalination plants, and then we will do the LCA of wastewater treatment, followed by the distribution and transportation, and then we will map those models on actual desalination plants in Saudi, and the whole data will be coupled together as a national emissions based database for water sector. So we have three prominent technologies for desalination in the market. We have MED, which is multi-effect desalination. It's more energy efficient, and it takes steam and electricity supply, but the market share is low as compared to MSF. MSF technology is old, and it also takes steam and electricity, but it's more matured, and the market share is huge. But as compared to those, the RO is much efficient, because if you compare the MSF and RO, the carbon emissions are by 3 times of the RO. So now we have conducted LCA of many technologies. This is for LCA of solar-driven MED technology, in which we compared the conventional desalination plant and the solar-driven desalination plants. And you can see that the climate change potential, which is equivalent carbon emissions, they are cut by 78% from 12.75 kilogram of CO2 to 2.75 kilogram of CO2, which means that like electricity and heat source may play the major role in the equivalent carbon emissions. We also carried out for one MSF plant, and we considered 3 different plants with different gain output ratios, and you can see that the equivalent carbon emissions goes from 13.6 to 8. The third plant is coupled with the nanofiltration. That's why the carbon emissions are very low, and you can see the same pattern in the for the other environmental indicators, such as ozone depletion, fossil depletion, human toxicity, and marine eutrophication. So currently, we are doing LCA of RO plant, and this RO plant is located at Kaust, which has a capacity of 10,000 meter cube per day for 1 train, and we have 5 trains. And the equivalent power consumption is around 4.5 to 5 kilowatt hour meter cube. So this is under progress. Also, at the same time, we are assessing the wastewater treatment plant at Kaus, which holds the membrane bioreactor technology. This work is also being carried out by an MSc student. So what happens with the data? So we will try to accumulate all the data, and we will represent in a kind of dashboard in which for each province the emissions related to water sector will be shown, And all the categories, you can choose all the categories on the left-hand side, and it will show what type of contribution from each source for any environmental impacts. Also, it will have other information regarding the desalination plant, type of desalination plants, and what are the pipelines within the kingdom, for example, Jubail to Riyadh and Buraida, and from Yambu to Medina, and what are the extra energy requirements for those water transportation. Also, we are planning to implement an online calculator in which a user can calculate water emissions based on the available data. And this is a screenshot which we have made in a Tableau, and we are still progressing. So that's all. So this dashboard will help in identifying the hotspots in the kingdom, and it will help us in decarbonizing the water sector, as well as the need to decarbonize the electricity grid. And these are some publications from our group, and that's all. Like, if you have.
Thank you, Dr. Furqan. Any question from our audience?
Thank you so much, Dr. Furqan, for your nice presentation. First of all, I'm not expertise in water. I'm from medical field. But what I understand that carbon dioxide do many pollution, and you have a solution to have it, because you say the electricity for the carbon emission go outside. So what I understand that carbon dioxide, it's good for the soil on the plant. I know talking is easy. You cannot put in your plan that we can do recycle for the carbon dioxide or other gases to the plant instead of that we discard it or emission it. Thank you.
Yeah. So first of all, our scope is to calculate how much carbon emissions are associated to produce 1 meter cube of water. So what happens with the CO2 is not our scope. What is our scope? Okay, how we are going to minimize those energy intensive process, maybe by increasing the wastewater treatment, because the carbon emission for wastewater treatment is much lower. So it will highlight the necessity that we need to look for other resources, and we have to lower the burdens on desalination. So that's how we intend to lower the carbon footprints. Also, and to integrate the renewable energy resources with the desalination plant. I hope this answers your question.
Any other question? Thank you, Dr. Furqan. Fighting agricultural threats. Up next, we delve into the world of agriculture and food security. From KAUST, Mohammed Jamil will guide us through strategies for managing root parasitic weeds, a critical issue in sustainable farming. Over to you, Dr. Mohammed.
So I am going to talk on a dangerous beauty, you can say. Actually, it is a very colorful and very beautiful parasitic plant which has serious threat to food security, especially in many African countries. So let's start. not coming. Yes. Sorry. So let's start with this beautiful pink-colored plant. Its name is Satriga. Sorry. And it is a root parasitic weed of many cereal crop, especially maize, millet, rice, and sorghum. So severe infestation of Satriga has caused 50 to 100% yield losses. That is equal to about 7 billion US dollar annually. Satriga has spread in 32 African countries, infesting about 50 million hectares, or 40% of total agriculture land in Africa. You can see these are some pictures of Satriga infested field which I captured during my visit in Burkina Faso, Kenya, Tanzania, and Niger. Recently, Satriga infestation has also been reported in Jizan part of Saudi Arabia, so it needs really an immediate attention to avoid further multiplication of this parasite in the kingdom. So the question is why Satriga is a problem. Actually, it attach to the root system of the host and start taking water, nutrient, impairing photosynthesis, causing toxic and pathological effects by disrupting host immune and hormonal imbalance, and finally death of the host. So this is the way it is damaging the cereal crop. So two key groups are impacted by this Satriga. One is small farmers and their families because of low production of this parasitic attack, and second, local consumers and local market because of less availability of cereals in the market. We can say Satriga is one of the main reason of hunger and poverty of 300 million Africans people, and it is at least affecting 1 out of 4 African people. A number of control measures have been proposed in the past, but most of them have partial or no success. I have reviewed them in plant physiology. Actually, controlling Satriga is a very challenging task. It is adapted to a wide range of host and environment, and its life cycle is very complex. Its seed require conditioning and host-released germination stimulant, and only one seed can produce 10 to 100,000 tiny seeds in one growing cycle that can spread very easily from one field to another field by wind and grazing animals. And last not least, the seed have very long life. They can remain viable in the soil up to 10 years. So in principle, 100,000 plant in 1 hectare can easily add 1 billion seed in one growing cycle. This is a huge amount of seeds. So we need to get to the root of the problem. These are the seed bank. If we can lower the seed bank, then we can expect less infection and ultimately more yield. So dealing with the seed bank could be one of the promising strategy. And we proposed suicidal germination technology to overcome this parasite. So what is suicidal germination technology? First, I want to explain life cycle of this parasite so that then you can understand what is our technology. So actually, as I said, under a normal condition, Satriga seed remain dormant, and upon conditioning under favorable temperatures, seeds ready to germinate. And when they get signals from the host, they germinate and develop a hostorium attached to the root system of the host, start taking water and nutrient, and then after few weeks, it come out of the soil, flower, and set seed for its future generation. So this is the life cycle of this parasite. So we are proposing this stage of life cycle to exploit. Actually, this is the stage when Satraiga seed perceive chemicals from the host and only germinate. So this is the normal case. As I said, Satraiga seed only germinate when it becomes sure there is a host nearby because it needs support. These are tiny seed after germination. So after germination, it attaches to the root system of the host and for water and nutrient. But what we suggested, we prepare these chemicals artificially. Same chemicals, which just to cheat the Satraiga seed. We apply these chemicals without host, just to show them, okay, just germinate. There is a host. So Satraiga germinate with these chemicals, but try to find the host. It will not get any host, and then die after a few days of germination. So this is simple suicidal germination, very simple technology. Death of germinated Satraiga seed without host. So in this way, we can easily clean Satraiga infested soil in the African countries. So Bill Gates Foundation funding us for the last 10 years just to develop this technology. It looks very simple and straightforward. Apply chemicals, induce Satraiga seed germination to dye them. But honestly, we faced three bigger challenges in this technology. First was simple, active, and efficient germination stimulant. For sure, we need this so that we can apply them in the soil. Second, a suitable formulation, because in the field we have to apply suitable formulation. And then third one is a suitable application protocol for African agriculture. So coming to germination stimulant, this is the natural stigolactone or germination stimulant released by the plant, which have ABC ring and D ring connected to a connected. And this is the artificial chemicals which was prepared before, but it is very, very expensive and very complex, need a lot of labor. So at least we cannot use this in the field. So then we discovered this very simple stigolactone, our germination stimulant. Its name was carlactone. It has only A and D ring. But problem, this is not very active. So then we redesigned these simple chemicals and make a number of other similar chemicals and screen them in our lab. And luckily at this time we found they have very nice activity for Satraiga germination. And then another set we prepared and screened them for germination and again found very active. So finally we selected these two very simple and active chemicals, MP3 and Nimegan-1, which are comparatively cheaper and very easy to synthesize. So we solved this problem. But problem is, again, these chemicals we cannot apply directly in the field because they are unstable in the soil. There is a poor absorption on the soil particles and hard climate in African agricultures. So we have to make just like them at a herbicide or formulated. Then we can, so that we can increase their life in the field. So then we contacted a leading agrochemical company. Its name, UPL India. So we asked them, these are two chemicals, so we need to formulate them. So luckily UPL India first prepared these two chemicals in a liquid formulation. It is emulsifiable concentrate. It is normally used in herbicide. So when we apply this formulated product in the field, then we confidently expect some good result. So this liquid formulated product is very user-friendly, handy, water-soluble, and stable. So we first tested these chemicals in our lab and found about 60% germination, And then we tested in greenhouse pot condition. We surprised to see there is about 99% control of Satriga with this product. So then we take this product in a Kenya infested field, and we found 25 to 39% control of Satriga with these chemicals. And in Burkina Faso, we observed 35 to 65% control of Satriga, and in Tanzania infested field, we observed about 58 to 72% control of Satriga. So very encouraging result with this product. Still, we were feeling that we need labor, sprayer equipment, and this is time consuming. Maybe there is some losses by wind during application. So why not? We should have some granular product, just like a fertilizer. We can apply and which need less labor. So UPL India again prepared for us this granular product of these two selected chemicals. So we can easily apply this product in the field and wait to germinate this Satriga seed, and then easily we can control Satriga seeds. As I said, so in our labs, we found about 60% germination from these granular product, and in greenhouse pot condition, we saw about 77 to 84% control of Satriga, and in Kenya field, we observed about 45 to 56% control of Satriga with these two granulated product, and in Burkina Faso, we observed 59 to 72% control of Satriga, and same in Tanzania, there is about 50% control of Satriga. But still, we need to improve the efficiency of these chemicals, and now we are working on this aspect. I will discuss later. So we develop the chemicals, and now we have no formulated form, but still there is only another one problem: application protocol. When we visited African countries, we observed there is a water scarcity, and mostly agriculture based on rainfall, and fields are mostly unleveled and poor soil structures. They have no mechanized agriculture. So these are major problems in Africa. So, but we have to develop a protocol. So keeping all this aspect in mind, we put a lot of efforts under mini-box and field studies, and finally we develop a rain-based application protocol. Let me explain quickly. Actually, in African countries, in summer, there are frequent rainfalls. So on the onset of first or second rainfall, we can say Satriga seed is ready. So on third or fourth rain, we can apply the chemicals, and then wait for another rain that can move the chemicals to the Satriga seed to induce their germination. And finally, when Satriga seed germinate with our chemicals, they will die because of lack of host. So this is very straightforward, simple, rain-based application protocol, which now we are using in African countries. So this is all what we have success story. So in summary, I can say we have developed very simple, cheaper, and easy to synthesize germination stimulant, which can be applied. These germination stimulant are available in a proper granular and easy formulation for field application, and they are very user-friendly, handy, and stable. And we have now developed a rain-fed based application protocol, suicidal germination protocol, and now we are successfully testing this technology in many African countries. I can say no, a day will come when African farmers will be able to clean their Striga infested field and will harvest enough food crops from their Striga free lands. So as I said, at this time, we are conducting field trials in 5 African countries: Burkina Faso, Niger, Ethiopia, Kenya, and Tanzania. And we will expect some good result, and we will try to register our product in these countries for general use in these countries. At the end, I am thankful to our collaborators, University of Tokyo, Japan, UPL India, Kenya, and Burkina Faso. And I am really grateful, especially Bill and Melinda Gates Foundation. They are funding us for the last 13 years. So last week, they again extend our funding for another 5 years to introduce these products in African countries. Coast is also helping us. These are my colleagues in my labs, and we have a Striga solution website for additional information. All information related to this technology project are available on this website. Thank you so much for your time and your attention.
Thank you, Dr. Mohammed. Any question?
Thanks for the presentation. How long does it stay active in the soil, or do you have to apply it every year?
Actually, at this time, we check the stability about 4 weeks. They remain active. Then, if we are lucky, rain occur on time, they induce the seed, then it will work. Otherwise, we have to apply again. So, but now we are working on some stable compound. But stability for longer time is also not good. It should be moderate, so it can cause residual effect. Then farmer cannot grow the crop in time. So 4 weeks at this time, they are much active.
Any other question? Thank you, Dr. Mohammed. Thank you very much. Rainwater harvesting at home. Imagine harvesting rainwater every household. What it take for this vision to become reality? Waad Ba'aql from Jeddah University is here to share insights from empirical study on consumer behavior and urban water sustainability. Waad, the stage is yours.
Ladies and gentlemen, thank you for joining us today in this presentation. We are going to talk about a very important subject, which is the water management. And I will present a study on the factor influencing customer intention to use water harvesting system in their home in Saudi Arabia. So the plan route for this presentation will be as follows. I will begin by giving an overview of the global water crisis. Then I will introduce the water management challenges in Saudi Arabia, followed by some sustainable alternative, and I will concentrate on rainwater harvesting technology. Then we will move to the challenges. of public acceptance and the public perception, followed by our research objective and methodology. Then I will present the model construct, hypothesis. Finally, I will give the experimental setting, result, conclusion, and future direction. So, the lack of water is a global major challenges that concern everybody. So we have 71% of the Earth's surface is covered by water. Yet just 3% is fresh water. So 2.2 billion people lack access to safely managed drinking water, and 4 billion people experience severe water scarcity at least 1 month per year. All these statistics highlight the urgent need for sustainable water management practice. Let's concentrate on the challenges faced by Saudi Arabia related to water scarcity. So the Saudi Arabia is known for its arid climate and limited rainfall, contributing to a severe shortage of water resources. Also, the country's rapid population growth and urbanization have aggravated the problem of water shortage, increasing the demand for clean water in domestic agriculture and also in industrial sector. Actually, Saudi Arabia is heavily relying on seawater desalination to meet its water need. This process of desalination is or requires significant energy input, contributing to high resource use. Also, this process has significant environmental consequences on marine ecosystem and also on the quality of air. So let's concentrate on the challenges related to the energy. The energy-intensive nature of desalination places a significant burden on the Saudi Arabia resource. It's often rely on fossil fuel, conducting to a high carbon emission and also to economic challenges. This process also impacts the environmental, it has environmental consequences. So desalination plants can harm marine life through seawater intake and bring discharge of highly concentrated salt solution. It also have severe consequences on air quality. So the energy production required for desalination often increases air pollution, affecting local air quality and contributing to climate change. Moving now to the economic implication. So the desalination infrastructure and operation require significant financial investment. So it is a lot of money. Also, the energy used for desalination reduce available resources for other sectors. So all the resources are allocated to desalination. The over-reliance on desalination may hinder effort of diversity on the economy. So this situation need more alternative solution. There are a lot of alternative solutions, including water recycling and reuse, renewable energy use, and groundwater management. So investing in advanced water, seawater or wastewater treatment and reuse technology is one solution. Also, powering desalination plant with solar or wind energy can also reduce the environment impact. Sustainable use and recharge of aquifer to preserve natural resource water also is a key sustainable solution. So we will concentrate on the first one, which is water recycling and reuse. Mainly in water recycling and reuse, we have two methods. The first one is gray water recycling, which is a treatment and reuse wastewater from sources other than toilet, such sink, showers, and washing machine. And the second method is rainwater harvesting, which is a method for collecting, storing, and using rainwater for various applications, such as irrigation, household use, or groundwater recharge. We have 4 technologies related to rainwater harvesting, which are rooftop collection, system that collect rainwater from building roof, direct it to storage tank. We also have the second technology, which is ground catchment, large-scale system that collect rainoff from paved area or specially prepared surface. The third one is filtering system technology to clean and purify collected rainwater for various uses. And we have also smart management IoT embedded system for efficient monitoring and distribution of harvested water. So, all the harvested water from rain can be used for multiple application, multiple use. We can, for example, talk about domestic use, household water supply for non-potable purpose. We can also use the harvested water for agriculture, like irrigation for urban farm and green spaces. Also for industrial use, water supply for industrial purpose, groundwater recharge, or also urban flood management for mitigating urban flood during rare heavy rains. So the question here is, does Saudi city have harvesting potential? So the answer is obviously yes. A study indicates that a considerable amount of rainwater annually can be harvested in Saudi Arabia city. A cost-benefit analysis also revealed that rainwater harvesting is economically feasible in cities such as Hail, Jeddah, Al-Taif, and Riyadh. So moving now to the benefit of this technology, which is water harvesting, rainwater harvesting technology. We will talk about the economic and environmental benefits. The first benefit is the cost of harvesting rainwater is lower than that of desalination water produced using renewable energy sources. Also, rainwater harvesting technology can significantly reduce greenhouse gas emission by minimizing the reliance of fossil fuel-powered desalination plant. The third benefit is rainwater harvesting can significantly promote water conservation and contribute to a more sustainable urban water management approach. Of course, there is a lot of other benefits, but we will just concentrate on these 3. So, to be able to implement this new technology, we have to study the public acceptation. So public acceptation is a key to a successful implementation of rainwater harvesting technology. The public acceptation and the preference play a crucial role in informing policymakers and stakeholders on designing effective rain harvesting system. Understanding this public concern and value regarding rainwater harvesting is vital for promoting the sustainable and practical use of this system. So now we will discuss some of the factors that can influence the public perception of this technology. We will begin by the factor that may negatively influence the public acceptance. The first one is the lack of awareness about the benefit and practicality of rainwater harvesting can hinder, of course, the public acceptance. Also, the cost. So the initial cost of installing rainwater harvesting technology is a significant barrier of many households. We have also 2 other negative factors. or factors that may negatively influence the public perception, which are the health risks and the maintenance. So for the perceived health risks, generally people avoid using rainwater due to the lack of evidence that rainwater is free for any harmful substance coming from the collected rooftop, and also for the maintenance, concern about the ongoing maintenance requirement and potential technical challenge associated with the system can affect negatively its adaptation. So let's move now for the positive factor. The first one is, of course, the perceived benefit. So consumer perception of the advantage of rainwater harvesting technology, such as water saving, cost effectiveness, environment benefit, of course, can influence positively the intention to adopt this kind of technology. The ease of use also, here we talk about the perceived simplicity of this kind of technology, which can also play a role in consumer willingness to incorporate this technology in their home. So we have also another factor, which is the perceived usefulness. So the degree to which a consumer believes that using a rain harvesting technology, water harvesting technology, would enhance his or her quality of life, and also the subjective norm, which are the social influence factor, the opinion and behavior of family, friend, community members, that can shape the individual decision on this kind of system. So the objective of our research is to examine the key driver and barrier influencing customer intention to use rainwater harvesting system in Saudi Arabia. For our methodology, we used three kinds of models. The first one is the technology acceptance model. The second one is the theory of planned behavior. And finally, the norm activation model. So we begin by using the technology acceptance model, which is a framework that examines how users adopt and utilize new technology based on two factors: the perception of its usefulness and its ease of use. We also use the theory of planned behavior, which is a psychological theory that links belief, attitude, intention, and behavior, and examine individual intention and behavior related to the adaptation of rainwater harvesting. The third model that we use is the norm activation model, which explains the pro-environmental behavior and understand how social norms and personal value affect individual decision to engage in rainwater harvesting activities. So we obtained a model with 7 constructs. So the first construct is related to the perceived benefit. The second one is related to perceived ease of use. The third is related to perceived usefulness. And the fourth hypothesis is related to subjective norms. They all positively influence Saudi consumer willingness to incorporate rainwater harvesting technology. We also have 3 other hypotheses which are related to perceived cost, perceived health risks, and perceived maintenance, which negatively influence the Saudi consumer willingness to incorporate rainwater harvesting technology in their home. So we obtained this model. As we can remark, the 7 constructs all influence positively or negatively the perceived attitude, which will positively influence the user behavior or intention to use this kind of new technology in their home. So the experimental setting is given as follows. So we use it for simple 400 participants constructing or planning to construct their home. The data collection was used with a non-probability sampling method, And to analyze the collected data, we used structural equation modeling using smart PLS software. So the result of this study revealed that the Saudi attitude have a significant impact on promoting their behavioral intention to use rainwater harvesting technology. To improve the attitude of potential user, the results suggest that policy should primarily focus on making the potential user feel and think that rainwater harvesting technology are very useful, easy to use, and safe for human. Government should implement taxes reduction on the cost of installation and also on maintenance, and also provide information about this new technology as a personal norm. So to conclude, this study, in this study we have concentrated on significant factors, which are the ease of use, usefulness, subjective norm, perceived benefit, cost, maintenance, and health risks. As future direction, we will expand the sample size and also explore additional factors. The application of this study is the funding of this study can guide policymaker and organization in promoting sustainable groundwater practice. And thank you for your attention.
Thank you, Dr. Awad. Any question, please?
Thank you very much. It was a very nice presentation, very clear. Thank you. My question is, you said that the rain harvested water can be safe for human. Although when the rain comes to the atmosphere, there is a pollution in the atmosphere, especially in urban area, industrial areas, there's lots of pollution. It could include sulfur dioxide, nitrogen oxide, ozone, and also dust. So that pollution, that is dissolved into the water, and that is, the water become a bit, sometimes like sulfur dioxide or nitrogen oxide could cause an acidity as well, so the water pH will be very lower, and that would be not safe for human consumption. But also, I think the collection of water will depend how they collect it, whether from the roof there are like litters of birds or some other stuff, whether that will also, make the water more not safe for human consumption. So what do you think about these issues for human consumption of the rainwater? Thank you.
Okay, thank you. So in this study, we concentrated on the consumer perception of the technology. So how they perceive the technology. Is it safe or no? It is not the fundamental question of this study. The fundamental question is if the consumer will say it's safe or not safe, okay? So there is a lot of technology that can be used to test the safety of the water, okay? But in this study, we just concentrate on the theory of acceptance related to human, not to the other technology for testing the safety or not of the water.
Any other question, please? Thank you, Dr. Awad.
Thank you.
Our next speaker for this session is Dr. Siddiq Ibrahim from Jazan University. Dr. Siddiq is a prominent researcher whose work focuses on leveraging technology to advance sustainability. He will be discussing exploring sustainability innovation in Saudi Arabia through mapping and visualization. Please welcome to the stage.
Assalamu alaikum and good afternoon to everybody. I would like to extend my gratitude to the organizing committee for organizing such important event on discussing sustainability innovations. Actually, my talk will be a bit different from other people because I'm not. My area is not sustainability, but during the COVID-19, so we developed new expertise on analyzing research. So when I saw the announcement for this event, I thought I have to share my the techniques I learned. So I collected all the research on sustainability innovation that conducted from inception to present and analyze all the research that has been done in Saudi Arabia since 1995 up to 2024, and just want to share how Saudi Arabia is doing in this sustainability research and sustainability innovation. So exploring sustainability innovation in Saudi Arabia through mapping and visualization. So today we will see how Saudi Arabia was doing and is doing, and what is the trending topics that Saudi will go. So important of research and innovation. So these all points, you know it. So it helps us to address environmental challenges, economic diversifications that align with the Vision 2030. So enhancing the quality of life, sustainability always help people to enhance their quality of life by promoting cleaner energy, efficient resources utilization, and reduce environmental degradation. So global leadership, Saudi Arabia is a key player in the challenging and that face through sustainability. So it also policy development and strategic planning. So research in sustainability is very important. So the significance of your study, I call it your study because I want to share this with you. So people working in sustainability research, policymakers, academicians, researchers, they can utilize the results of this study so that they can map the current efforts, what people are doing now in sustainability in terms of research, in terms of innovation. So what are the gaps and opportunities that we can see from our analysis? And then we can also collaborate, because from here we can see that Saudi Arabia is very active in terms of scientific collaboration or technical collaboration in sustainability innovation. So the results also can help decision makers like SAFTA or KAUST or the Ministry of Agriculture. So it can help them to tell them who is the hot spots, what are the main topics like that. So impact on global research. So Saudi Arabia also is contributor in this, and also the results can support the vision. So because they are looking for 2030. So what we are doing now in terms of sustainability. So this is one of the analysis that can help to see what we are doing. So I'm using bibliometric analysis, which is the analyzing of research or regeneration of science. So this technique, so by using this technique, we can identify research trends, mapping conceptual frameworks in sustainability and innovation, assessing intellectual structure like what are the key contributors, understanding collaboration patterns, because you cannot work alone, and sustainability is a global issue, so we have to understand and measure the collaboration, quantifying research impact, and benchmarking research performance, exploring policy and practical, and how we can see the dynamics of research, because how the research start and like that. So identifying funding and institutional rules. So if there's anyone from like RDIA or from the ministry or from there, he can know that so who to fund and who like that. So supporting strategic research planning. So whatever I did, actually, I designed terms that terms I use it to search about sustainability, innovation, and research in the Scopus database. So I downloaded around 5,103 articles that concern with sustainability, innovation, and research. And after downloading them, I used two softwares that are available. One is R-based package, and the other one is Voice Viewer, and they are open source. So these two softwares, I use them to analyze what people are doing now or in the past in Saudi Arabia in terms of sustainability, research, and innovation. So the analysis has two parts. The first part is the intellectual structure, and the second part is the conceptual structure. So when we talk about intellectual structures, so we want to see identifying the figures or the hot spots. Who is the prolific, researchers? Who's the top universities that has participated mainly in sustainability research, and conceptual structure also help us to like the framework of because sustainability research is a very big topic. So that whether Saudi Arabia cover all these topics or we are working on certain areas. So this is including topics, themes, and relationships. So my presentation is a bit different. So I hope that you may see. So see, this is the annual production of documents per year from Saudi Arabia that related to sustainability, innovation, and research. So in 1995, there is one document, but in this year, Saudi Arabia managed to publish 1,684, or 48. So with annual growth of 29%, which is good, but and I'm expecting that Saudi Arabia will do better than that. So this is from 1995 up to 2024. So this is the annual growth. I'm seeing it is very, very good. So key contributors in sustainability innovation. So this is like the truth. So who is doing? So these are the best or the top researchers based on their production, not based on their impact. So these are the best. So in these 5,000 documents, there are 20,562 scholars participated to produce this research. So the top, like these are the names. So I'm going to go fast on the names so people can be encouraged. So King Saud University is the top institutions, followed by King Abdulaziz University, King Fahad, and then these are the top. You want to take a picture? So this is the top institutions that participated in the. So, and as you see here, this map was produced by the software, and will tell us how Saudi Arabia, research is globalized. Like many countries participated with Saudi Arabia in their research. So, and this also diffusion of knowledge. As you know that now we have listened to one of the researchers from Jeddah University. She is discussing sustainability of the social acceptance of one of the sustainable. So Saudi Arabia research in sustainability is very diffused in other areas of research, like in environmental, in energy, engineering, social sciences, computer science, material science. All the people from many disciplines, they are eager. They are working on sustainability, innovation. So, and these are actually, when we publish a paper, so the paper either to be original article or data-driven study or review. So when we see that 70% of the sustainability research in Saudi Arabia is original research, that is a good measure. So people are doing research like that. But if, let's say, most of them are reviews, so people are sitting in the office and just writing papers, reviews like that. So this is another indication of the, also this is the biggest funders, King Saud, like, because I think because of it is one of the eldest universities, so they have invested a lot of money on funding sustainability, research and innovation. So this is the international collaboration. This is mapping and visualization. So this is the two words that I put in my title. So how to visualize, how to map the research collaboration of Saudi Arabia. If you see here, we have 7 colors. These 7 colors represent 7 clusters of countries that are working together. So we can see that Saudi Arabia has many international collaborations with many different, like maybe the red, if you see the red colors, normally they are European countries. The yellow ones are like, some of them are Islamic countries like that. So these are the mapping of it. So here, when you see the green color is a single country publication. Green color is a single country publication. This is what Saudi Arabia produced independently without, collaboration. But the biggest collaborator in sustainability research and innovation with Saudi Arabia is China, followed by India, Pakistan, Malaysia, Egypt, USA, United Kingdom, and Korea. So this is also like, this slide can help the policymakers, like where to go, why we did not go there like that. So this did help us, the policymakers. So this is the dynamics of collaborations. So the yellow box are the latest countries that Saudi Arabia joined in collaboration. So, but the purple one are like before 2020. So like Cyprus, Uzbekistan, Taiwan, Lebanon. This yellow countries are, we just recently, Saudi Arabia, joined them in collaboration. So these are the collaboration when we want to know who is the best collaborators, like who is the top collaborators in Saudi Arabia. So if you can see here that it is very big map. Saudi scientists are, collaborating with many colleagues from other countries. So this is the intellectual structure. So like just descriptive to what is going on. So the second part of the presentation is about the evolution of the technology, the sustainability technology and research. So when you see that in the first 27 years, people are working on this topic, like photocatalysis, biomass, they are working on this topic. But recently or last year, the topics has been changed. So some of the topics preserve their spots and some of them are changed. But this year, maybe because of funding or because of some international trends, people concentrated on like 4 topics. And this analysis is based on the most frequent keywords, but not all the keywords. So we use the most frequent keywords. We have 3 shown when we want to do the programming for the software. But this is the evolution, and this map is produced by the Arbakish bibliometrics. So from here we can understand that the research in innovation, in sustainability, is dynamic and is changing and is So this is the conceptual structure. So what are the topics that people are doing? But this is we can take from here rough ideas. So based on colors, each color represents a research cluster. Each color represents a research team. So from there we can see that the green color, people are working on wastewater treatment, biomass, biochar. So, and the purple one, people are working mechanical properties maybe of some materials. So this is the teams like that. So we will go deeper on this analysis. So this is based on author keywords. So when we submit papers, we put some keywords. So we take these keywords and analyze. So what the people do. So this is the map of the most frequent 50 keywords. So from here we can see that what are the people did. So this is based on keywords from the title. So this is the most important part in the second part, so from here we see that there are 5 or 6 teams of Saudi Arabia research in sustainability. So they will explain them more. So we call them. So there is people interested in machine learning and sustainability. There are people also working on absorption, wastewater, sustainability itself. People are working on sustainable development, mechanical properties, and these are the label of the teams. They are not the teams. So under this, there will be also some different topics. So what people, machine learning can do, highlight the role of advanced computational method on optimizing sustainability practices. So these are just more explanation of the teams. So like mechanical properties. So this team, what people do, suggest are interested in material development, testing, particularly. So if you can see some of the booths there, people are recycling some of the waste. So they want to know the mechanical properties of the new materials. So this is the research focus of the. This is we run also analysis to know the emerging trends. What are the emerging topics, or what are the trending topics in Saudi Arabia? So these topics are green innovation and also sustainability or sustainable development goals, natural research, sustainable development, renewable energy. These are the trending topics. From my presentation, this is the last slide. So a comprehensive study from inception to date, because this is from 1995 up to the submission of the abstract. So we have the first of its kind to assess the research in this area. No previous studies to assess the research in Saudi Arabia that is concerned with sustainability. The data used the largest database to extract the bibliographic data, because I use Scopus. Scopus is the largest database. So the number I used, that 5,000, if I went to another database, it will be less. So, and then the performance and the thematic structure was analyzed. The annual growth is 29%. The top prolific scholars from various fields, which means that, the culture of doing sustainability, innovation, and research is very promising. Active universities are mainly from the capital city, so people will have to give us some fund for Jazan universities and all this. Data-driven studies are 72, so people are doing real research. King Saud University provides the largest fund, which is 14% historically. Saudi scholars are active in international collaboration. The global partnership is dynamic and active, because we see that recently Saudi Arabia joined some countries to do some sustainability research. Thanks.
Thank you, Dr. Sadiq. Any question from our audience?
Hi. Does that work? Yeah. 2 questions. So firstly, the rate of growth. Do you think that will continue? You were showing something like 1,600 papers in the last 12 months. Do you think that rate of growth will continue? And secondly, as you said, sustainability is a very broad topic. Are there particular trends that you think will be of particular interest as we go forward over the next 2 to 3 years?
Okay, I think there will be increasing of the articles because the percentage of 29% is promising. So I believe that people will be more interested on sustainability, innovation, and research. And regarding the diffusion of knowledge, so I'm sure that there will be, like, from morning to until now, if we just see the background of the speakers, we feel like we are in the university campus. So people from different fields are, giving their input on the sustainability. So I believe that. So.
First of all, thank you so much. It's a very detailed study, and being a researcher, I can understand how much time and effort it requires. So well done. My very brief question: you mentioned that there were some software which helped you in analyzing the data and extracting the data. And you mentioned one of the package in R. Can you please mention the name of that package for me, please? Because I'm an R user and I want to see how it works actually. Thank you so much.
But we have to share the publication later.
Yes, thank you.
The package in R called Bibliometrics. It is a web-based interface. So when you go, you just write library, Bibliometrics, enter, then it will bring, then you have to write BiblioShiny. So there are two packages. So the main one is Bibliometrics. The operating one that appears as interface is BiblioShiny. So it's very straightforward. Actually, I learned this one during the COVID-19. So I'm a pharmacologist, so I have to go to the lab, no lab, so we have to produce research. So what is the available things is to go for this one. So I learn it, and then all are free softwares.
Any other question? Thank you, Dr. Sadiq. Artificial intelligence and groundwater sustainability. Our next session explores the intersection of artificial intelligence and groundwater management. Please welcome Dr. Fakhruddin from Digital Petroleum Company, who will demonstrate how AI is revolutionizing groundwater simulation.
شكرا. السلام عليكم، حياكم الله. معكم المهندس فخر الدين. So I am the CTO of Digital Petroleum. Dr. Manal is supposed to be here with us, but for logistic issues, so I will be presenting this. So thank you for this opportunity and selecting our paper. We have presented this year as well during the Saudi Water Forum, and today, inshallah, we'll go through in details and we'll show how far we went with this approach and application. So today, what's the main issue that we are facing within our region? Water stress. I think we heard this many times. Al-Jafaf, yani water stress is a very big issue that keeping us thinking every day how to solve this and how to mitigate this before we face the big challenge. So our aim, our goal, what we want is to reduce this water stress and extend the water reservoir life within our region, especially in MENA, Middle East and North Africa. So what we did first, we analyzed all root causes that causing this water stress. So mainly the reservoir depletion, the fast depletion that's happening, the non-respect of regulation, illegal drilling that's happening, especially with small farmers, and the absence of water quality monitoring. Water quality is very important for for the farm industry. So, and we even analyzed the financial impact of it. Then we said, how can we solve this? So how can we solve the illegal drilling? How can we solve this reservoir fast depletion? By monitoring, alerting, and predicting, especially the prediction where the AI model will play a big role on this. So this is the approach. This is, you can say, the schematic that we are using. So that include AI and IoT, how it will communicate to the water reservoir, especially the water wells, and the AI algorithm will do the interpretation and the prediction of this. So it's an application that we have developed as well, even for small farmers. So the data acquisition step is very important, okay? And it will, our PhD and reservoir engineer, after that, he will work on the mod flow. So it's like the simulation step to simulate how big is the reservoir, and and then we'll see if we need more data or not. Then the visualization, where we'll see the simulation, what the simulation is giving us. So without going in complication, this is like how we developed all of this, and especially communicating from the sensor, the water well sensor, to know the water well level and see if there is any fluctuation on that water level. The AI model will translate this to a fluctuation on the reservoir quantity. So this is how we always try to update the reservoir data. So just to summarize out of this, so first step, we input the data, then define the right model. This is what we call the numerical model, and do the simulation analysis, and then the prediction. Once you have the simulation done on the mod flow, then the next step is your AI prediction. So this input of this will be the mod flow. It will be inputting on your AI model, and then we will predict two things: the groundwater level for the next 40 years. This is what we are targeting. This is where we are expecting to have a high water stress. In the meantime, AI for calibration, okay? Instead of doing resimulation, the AI can help to optimize this calibration modeling. So once we have the prediction done, what we want to do is we want to get ready for different scenario. So in this, you will have to do multiple predictions. So scenario one, like a climate scenario, forecast to the recharge. So we want to use the recharge want to use that for recharging some water reservoir, and test different groundwater levels to set the right limits. And the land use. Land use is one of the major things. For example, today, if we have a reservoir, okay, and this is how, this AI model will help even for the urban city construction. If you have a reservoir and you're expecting this reservoir life to be stronger and for another 40 years, you should not have a heavy construction above it, okay? It's better to use it for agriculture use. So this is where this is the use of this application. So people who want, on the urban side, on the smart city side, they need to know how long this reservoir will stay, so they can plan for the city expansion. So this is very important. Even on the dam side, where you want to plan the dam, you need to know how big the reservoir and the reservoir life. So this application became very important in terms of planning. Planning and planning and planning. The benefits, as I mentioned, planning is one of them. Optimizing the resource by increasing the reservoir life is not, and proactive management, like the strategy for any government or any water any water entity, if they know with the AI prediction models, if they know, for example, this reservoir will not be that long, okay, then we have to forecast and plan things from now, okay? This is very important. So this is a screenshot from a platform that we developed for farmers, because farmers, they need this kind of information as well, even small farms, okay? So because he's the guy who is suffering from doing frequent drilling. So he's drilling today, and he's drilling after 4 days. So we don't just want to tell him, hey, do not drill, otherwise you will have a sanction. So we want to have him part of us, part of our team, and he has to be aware that there is no need for extra drilling. Today he has no information to decide about this. He just simulates by his experience, okay, I have to drill another well after 2-3 years. I think my well is already depleted, I have to drill more. No, with this, it will tell him how the life of your well, okay? And it will allow him even to do a remote control of the pump that he's using to produce the well and the aquifer of the life. As well, he can see the quality of the water, if the salinity is high or no. So we only need one thing for this. We only need to have an IoT sensor along with that pump. This is a use case that was done in Tunisia, okay? So it illustrates the steps of this. So we select the data, we select which area, the reservoir, then we do the 3D modeling on the mud flow, and then we create the AI algorithm with LSTM here, and then we predict, if you can see there, till 2100. So we predict the groundwater level for all that period using as an input the mud flow simulation data. And this will help us to strategize, to plan many things from now, to be aware about the reservoir life. Conclusion, so by combining AI and IoT solutions, government, especially government, and this is why today we are talking and discussing this with the Saudi Water Authority, they can have a command center for all water wells, and from that, they can know the reservoir, and they can predict the reservoir, and they can control remotely to extend the reservoir life. So this is very strategic and important. This will help in the future to do what? To avoid the water stress, to plan for city expansion, to plan for any new construction. So this is very important from strategic point. AI and IoT, emerging technology, can play a big role there. So thank you for your attention. I hope you have more questions, and we are ready to answer.
Thank you, Engineer Fakhruddin. Do we have any question from our audience? Thank you, Engineer Fakhruddin.
شكرا.
Next, we have Mr. Khadr Al-Ghamdi from Arak Farm with a deep commitment to sustainability agriculture. Arak Farm has been at the forefront of innovation in farming practices.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على سيد الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. اليوم حنتكلم عن تجربة فريدة على مستوى المملكة العربية السعودية والشرق الأوسط، بل على مستوى العالم، اللي هي زراعة الأراك بمياه البحر والمياه المالحة. لله الحمد والمنة، وهذه الشجرة ليست غريبة على مجتمعنا. هذه الشجرة ليست غريبة على مجتمعنا، بل هي من مجتمعنا، ولكن الغريب في الموضوع إن زراعتها بماء البحر. الشجرة هذه أحد أسمائها اللي هي شجرة الأنبياء، وهذا من أحد أسمائها شجرة الأنبياء. نحمد الله ونشكره بفضل الله عز وجل. هذه من الشجرة هذه حنا المقصد بها اللي هو التعريف بالشجرة والتعريف بما استقبلها من منطلق مستقبل من منطلق مستقبل الابتعاث الحراري والكربوني والتغيرات المناخية في المملكة العربية السعودية وفي منطقة الشرق الأوسط، ومن ضمن مبادرة سيدي ولي العهد السعودية الخضراء. نحن في مزرعة أراك القضيمة نساهم بجزء بسيط وقليل في المساهمة في تغير المناخ والتعديل، لأن الشجرة هذه تخفض درجة الحرارة من 4 درجات إلى 7 درجات علميا، وتخفض درجة حرارة الأرض من 20 درجة إلى 35 درجة تحت أشعة الحمراء. مزرعة أراك القضيمة لها بفضل الله عز وجل تجربة أكثر من 25 عام، وحنا في التجارب بفضل الله عز وجل من ضمن التجارب ومن ضمن الأوقات، وبفضل الله عز وجل نجحنا في زراعتها على ماء البحر. ولنا الآن عندنا تجارب لله الحمد والمنة، قد زرعنا جزء كبير بفضل الله عز وجل، وزرعنا ما يقارب 250 ألف في جميع أنحاء المملكة، وزرعنا الحمد لله عندنا الآن في المشاتل حقتنا وفي المزرعة 4000 أمهات، وعندنا فوق 120 ألف، وعندنا فوق 120 ألف، وعندنا فوق 4 ملايين من البذور. شجرة الأراك المعروف عنها دائما وأبدا كان يتبادر لدينا أنه بس المسواك، لكن شجرة الأراك النبي صلى الله عليه وسلم ما يوصي في شيء إلا فيها الخير الكثير. ويقول النبي صلى الله عليه وسلم: لولا أشق على أمتي لأمرتهم بالسواك عند كل صلاة إنه مطهرة للفم مرضاة للرب. لو ندقق عند الكلمة هذه الأخيرة مرضاة للرب، جميع أعمالنا نقصد بها مرضاة الله عز وجل. وفي الحديث الآخر قال: كنا مع النبي صلى الله عليه وسلم نجني الكباث، فأوصانا من الأكل منه الأسود، وفاكهة الكباث ما يعلمها إلا القليل. بفضل الله ونعمة من الله عز وجل وتوفيقه، لقد قمنا بزراعتها في شمال المملكة العربية السعودية في نيوم، وقمنا بزراعتها برضو في أرامكو في شاطئ الرمال البيضاء، وبلغ نجاحها بنسبة 98%، وهذه نعم من نعم الرحمن. رؤيتنا بفضل الله عز وجل نتمنى أن نشارك وأن تكن زراعة شجرة الأراك في جميع مناطق المملكة لتوقيف منها التوقيف سحف الرمال، وهي شجرة في الأصل شجرة صحراوية. الشجرة شجرة صحراوية، شجرة رعوية، شجرة طبية. تعريفها شجرة طبية رعوية يأكلها الإنسان والحيوان وانتم الكرامة، ولها فوائد كثيرة، وقد طلعنا منها أكثر من 13 منتج، سواء طبي أو سواء قهوة أو سواء شاهي أو سواء، وفيها فوائد كثيرة جدا. ودائما وأبدا سبحان الله نعلم بعض الأمور وبعض الأمور لا نعلمها، وهي حديث النبي صلى الله عليه وسلم وهو ما ينطق عن الهوى إن هو إلا وحي يوحى. من منطلق رؤية سيدي ولي العهد حفظه الله ورؤية السعودية الخضراء، أردنا أن نساهم حتى لو بأجزاء بسيطة من ضمن الرؤية. حنا في المملكة العربية السعودية كما تعلمون لا نعاني من قلة المياه. قلة المياه لا نعاني منها نهائيا. قلة المياه، حنا نعاني من قلة المياه الصالحة للشرب والاستهلاك الآدمي. أما مياه بحر فنحمد الله ونشكره، وعلى مستوى المنطقة الشرق الأوسط. أما مياه البحر والمياه الأخرى فالحمد لله مياه متوفرة كثيرا. هذه الشجرة ميزتها تعمل على جميع أنواع المياه، مياه حلوة، مياه مالحة، مياه، جميع أنواع المياه فهي تعمل عليها. وهذه من نعم الله عز وجل، من ماء التحلية إلى 110,000 إلى 70,000، وبعد 70,000 نبدأ ندرجها إلى 110,000، وهي تعتبر زراعتها في الملاحات. والتجربة موجودة والحمد لله على الواقع وموجودة. هذه بعض المبادرات وبعض المشاركات في شاطئ السيف في جدة على شاطئ البحر، وزرعت والحمد لله ونجحت بنجاح باهر وبفضل الله عز وجل. عندنا في المملكة العربية السعودية نعاني من الزحف الرمال، وهي زحف الرمال عندنا سواء في الخطوط السريعة وخطوطنا مترامية. نحن في قارة، سواء خط المنطقة الشرقية الجبيل كم تصرف عليه الدولة في المعدات وكم تصرف، وهذه إن شاء الله إنها تكون من ضمن الحلول. خلافة إن نستورد المسواك ونستورده بنسبة عالية جدا، وهي استيراد عالي جدا. بعدين تساهم هذه الشجرة تساهم في أشياء كثيرة، تساهم في فتح الأسر وفتح أسر أنتجة، وظائف جديدة، مزارع، ولها مساهمات عدة. هذه بعض التكريمات. هذه كرمنا من شركة أرامكو في الزراعة في شاطئ الرمال البيضاء، وهذا تكريم من جامعة الملك عبد الله للعلوم والتقنية. وهذه اللي أسفل فاكهة الكباث، الذي ما يعرف فاكهة الكباث، وهي فاكهة موصي فيها النبي صلى الله عليه وسلم وتاج على 3 ألوان. هذه بعض المعارض، ولله الحمد والمنة لنا مشاركات في معارض كثيرة، والحمد لله لنا مشاركات عدة في المعارض والمحافل. هنا فاكهة اللي هو المسواك. المسواك له فوائد كثيرة، مطهرة للفم، مرضاة للرب، ويطلع منها منتوج. من المنتوج هذا منتوجات كثيرة لصناعات تحويلية كثيرة جدا، صناعات تحويلية كثيرة جدا، والدراسات واسعة في هذا المجال، ويلزم البحث والاستمرار فيها لأن فيها دراسات جدا. عندنا فاكهة الكباث. هذه فاكهة الكباث تاجي 3 ألوان، اللي هو اللون الأبيض واللون الأحمر واللون الأسود، وكلها فيها خير، والنبي صلى الله عليه وسلم أوصف اللون الأسود. هذه البيئة، ولما نتكلم عن البيئة وما البيئة، هذا لما تكون عندنا منطقة صحراوية أو حنا على طرف أحد الشواطئ، في أحد الشواطئ، أو استهدافنا المناطق الصحراوية والرمال المتحركة والمتجرفة، بفضل الله عز وجل لما تكون منطقة خضراء على شاطئ البحر أو في المناطق الربع الخالي، المناطق المستهدفة الرملية والمناطق الصباخية نستهدف بها هذه الشجرة، وهذه الشجرة تصلح على جميع أنواع المياه. من أكبر من نعم الله عز وجل إنها تنزل الحرارة، ونقدر نعمل تتشكل معنا هذه الشجرة إلى عدة أشكال، وترتفع على مقاسات ترتفع علميا إلى 20 متر، والآن موجودة عندنا على أرض الواقع فوق 8 أمتار. والشجرة ممكن الشجرة الواحدة تغطي مساحة 20 متر مربع إذا تركت على وضعها. وفي الإمكان الثاني إن نقدر نزرعها، نستفيد منها في الشوارع، نستفيد منها في كل شيء، لأن الشجرة هذه توقف على ساق واحد. هذه بعض الأشجار التي قمنا بنقلها، والحمد لله زرعت منها في الدرعية، زرعت في تبوك، زرعت وعلى عدة مقاسات وعلى عدة شتلات. هذه كثافة المسواك. الصورة الثانية كثافة المسواك وكثافة الإنتاج، وهذه إنتاج رائع جدا واقتصاد عالي، ويشكل اقتصاد رائع جدا. فاكهة الكباث نرجع لها مرة أخرى، وهي عائد رائع اقتصادي جدا، وليست موجودة في الأسواق بل تنقص كثيرا، وهي فاكهة غير معروفة، وهي غالية الثمن وطبية علاجية غذائية. هذه ألوانها ألوان جذابة جدا، سواء اللون الأسود واللون الأحمر واللون الأبيض. الطبيعة شيء رائع جدا، ولها رائحة نفاثة، لها رائحة نفاثة لشركة الأراك. هذه نقدر نعمل من شجرة الأراك على عدة أشكال، نقدر نعمل منها على عدة أشكال. نقدر نعمل منها مخيمات طبيعية، نقدر نعمل منها حواجز، نقدر نعمل حواجز لزحف الرمال، ونقدر نعمل منها أشياء كثيرة. والشجرة ما شاء الله تبارك الله ترتفع، وعندنا فوق 20 بوصة سماكتها، وارتفاع فوق 8 أمتار. هذا يزورنا بعض المهتمين والخبراء، ونستقبل طلبة الجامعة والدكاترة والمهتمين والباحثين، نرحب بهم للمشاركة والاطلاع على مشروعنا وعلى تجربتنا والاستفادة منها وتفعيلها بشكل أكبر إن شاء الله. هذا ما شاء الله تبارك الله، هذه شجرة، شوفوا كيف، وهذا طالع كيف عرض كم بوصة. وهذه أشجار، هذه جاهزة نقدر ننقلها على أي محل على ساق واحد. هذيك الخيمة طبعا تحت شجرة أراك، يعني تحت شجرة الأراك. ما نملك إلا نقول نسأل الله العلي القدير رب العرش العظيم أن ينفع بهذه الشجرة، وأن ينفع بالجهود، ونشكر الجميع للاستماع. وإذا في أي سؤال مستعدين، حفظكم الله.
شكرا جزيلا السيد خضر الغامدي على هذه presentation. Any question from our audience? أي سؤال من الجمهور؟
السلام عليكم. ما شاء الله تجربة مميزة، ونسأل الله ربنا سبحانه وتعالى أن يعني يوفقكم وتبنيكم للسنة النبوية، وتستفيدوا منها في الدنيا والآخرة. هل بسأل عن المنتجات ال11 اللي انت قلتهم، ولانه احنا كنا عايشين في آسيا فترة كده، فكان في معجون من المسواك، معجون يعني سووه من المسواك، فهل حاولتوا تدخل في أعمق في الصناعات التحويلية؟ شكرا جزيلا وبارك الله فيك.
الحمد لله فيه، الحمد لله منها يطلع المعجون، ويطلع منها اللي هو زيت الأراك من زيوت الطيارة، وتطلع منها أشياء كثيرة تستخدم في الأدوية. طلعنا منها الشاهي، طلعنا منها القهوة والشاهي الأخضر والشاهي الأحمر، وطلعنا بفضل الله عز وجل برهم اللي هو للأكزيميا الشديدة، وطلعنا إن شاء الله برضو بودرة للجروح السريرية، جروح السكر والجروح السريرية، وإن شاء الله أنها ترى تكون في الأسواق في القريب العاجل إن شاء الله.
السلام عليكم. أخوكم المهندس علي الشيبان، وزارة الحرس الوطني، مدير إدارة التشجير. الحقيقة التجربة فريدة، يعني احنا اليوم يعني من أكبر التحديات اللي موجودة في المملكة وتواجهنا في موضوع التشجير موضوع المياه، والمملكة محاطة يعني من الشرق والغرب بالبحار، وهي فرصة في الواقع لأن احنا نستفيد من هذه التجربة للتوسع في أعمال التشجير في خصوصا على يعني مناطق الصبخات ومناطق البحرية. لدينا حدود كبيرة جدا على البحر الأحمر وكذلك على الخليج. وأنا يعني أنقل السؤال أيضا للأخ خضر على موضوع التجربة، هل تم نقلها إلى المنطقة الشرقية أو زرعت؟ احنا نعرف أحيانا قد يكون المناخ أو غير عن التحدي المائي، قد يكون حتى المناخ قد يكون له تأثير بشكل أو آخر، إما أن يكون إيجابي أو سلبي. فهل تم تجربتها على في المنطقة الشرقية على شواطئ الخليج العربي؟
الحمد لله تم تجربتها في المنطقة الشرقية على شكل فردي، ولكن الحمد لله أثبتت نجاحها وناجحة جدا بفضل الله عز وجل. وميزة الشجرة هذه أنها تستحمل الحرارة الشديدة، وكل ما كانت الحرارة شديدة كل ما كانت سبحان الله، وهي ديمومة الخضرة، ميزة من ميزاتها طوال العام ديمومة الخضرة، وهذه مما نحتاجه. وتمتص ثاني أكسيد الكربون بنسبة عالية جدا، والحمد لله نجحت في المنطقة الشرقية ونجحت في أكثر مناطق المملكة، جربناها في جميع مناطق المملكة. أحيانا المناطق الباردة يكون الباردة شديدة، إذا كانت على الأشفية تكون النمو حقها بطيء جدا. أما المناطق الداخلية جربناها في الرياض ما شاء الله، جربناها في جميع مناطق المملكة والحمد لله ناجحة وتصلح لجميع مناطق المملكة. ولو ناجي نبحث كصفة عامة نحصل في جميع مناطق المملكة آراك، سواء قل أو كثر، ولكن جميع مناطق المملكة، وهي كانت من ثقافة، ومعروف أنها من ثقافتنا، وكانوا مو معقول أنه بيروح من بلد إلى بلد في القديم، كان التنقل صعب، وكانوا يزرعونها في جميع مناطق المملكة.
أعطاكم الله العافية إن شاء الله وبارك الله في جهودكم. عندي سؤالين بسيطة. أنت تكلمت على أن كان عندك 150 غرسة، وصارت اليوم كم عددها اليوم؟
الحمد لله الموجود عندي الآن 4000 أمهات، وما يقارب 120,000 ولا هي أكثر، بس نحط الحد الأقل دائما 120,000 شتلة موجودة، ووزعنا في جميع أنحاء المملكة، اللي زرعناها في جميع أنحاء المملكة فوق 250,000.
وعلى مساحة كم الله يحفظك؟
والله هي كانت أكثرها اللي هي على مساحات معروفة، اللي هي حقت أرامكو واللي حقت نيوم على مساحات معروفة، الباقيات كانت تجربات فردية، وتعرف المزارعنا والمزارعين وعلى تجربات فردية.
أنا أقصد المزرعة.
مزرعتي أنا مساحتها تقريبا 75,000 متر مربع، وأتمنى من المهتمين والباحثين أنه يروها على أرض الواقع، لأن الرؤية تختلف. الحمد لله يعني نعمة من الله عز وجل. الشجرة هذه ترى شجرة مزارعة، خلافا عن هي شجرة مزارعة، يعني بتزرع شجرة وهي شجرة مزارعة. عمرها يعني عمرها تقريبا 120 عام علميا، علما أن عندنا أشجار في المملكة العربية السعودية شجار أراك فوق 400 سنة، ومنها شجرة الراكة في الأحساء.
آخر سؤال واعذرني على الإطالة.
لا تفضل.
أنت ذكرت أن عندك مخزون للبذور، هل في أي مشاركات أو أحد ممكن يعني يستفيد من البذور هذه، أو كم عددها بالضبط؟
عندنا فوق 4 ملايين بذرة، نود أنه إن شاء الله نستفيد منها، وعندنا إنتاج سنوي، وإنتاجنا السنوي عالي جدا، وهي ما شاء الله تبارك الله زي ما رأيتم في الصورة، هي تجيب كباث كثير جدا بفضل الله عز وجل، وهي عندنا إنتاج عالي جدا، ونتمنى أن يكون فيه لها دعم. أنا إلى الآن أشتغل شغل يعني تقريبا جهود فردية، والجهود الفردية نتمنى أن نوصل جهود مؤسسية وجهود أعلى، لأنه هذا ليس مشروعي أنا، بلا مشروع بلد ومشروع المملكة العربية السعودية، وهذه تجربة سعودية 100% خالصة، تجربة سعودية 100%. نتمنى أن نراها إن شاء الله في جميع شواطئنا، نراها تثبيت الرمال زي خط عمان، زي خط الشرقية، خط الرياض، في مناطق كثيرة جدا نحتاجها، ونحتاج الكربون، سوق الكربون الآن، وهي تمتص نسبة عالية جدا من امتصاص الكربون. نحتاج الآن، عندنا مشكلة بدت تطالب بها العالم، اللي هو ترجيع الموية لنا، رجعوا البحر. قالوا طيب بعد كم كذا، ليش حنا ما نرجع على الشاطئ؟ البعض يقول لا نصبخ، حنا ما حنصبخ اصلا، ان البحر اوردي. نرجع على الشاطئ فترة كم في المناطق، ونقوم بزراعة الشواطئ بالرجيع حق التحلية، ولا يرجع البحر إلا قد تصفى ورجع مرة أخرى كدورة، كعمل دورة. عندنا الآن البيئة والاستيطان، البيئة واستيطان الطيور، هذه من أكبر استيطان للطيور في البيئة، وتغيير البيئة وتغيير المناخ. لما نزرعها في الجزر؟ عندنا جزر فيها طيور وفيها أشياء تأكلها، تتغذى عليها الطيور. المناطق التي المستهدفة عندنا المناطق التي ليس فيها زراعة، التي لا تصلح فيها الزراعة. البعض يتكلم وعدة أسئلة أسألها، يقول أنت بتصبخ الأرض. أنا ما قلت أجيب موية من البحر، الشجرة هذه تعمل من موية تحلية إلى موية بحر، هي من ضمن التحديات. المنطقة اللي حنا فيها، بدل إني أنا ما أجيب لي صهاريج وأجيب لي كل شيء، المنطقة التي مويتها فيها طبعا الموية بتكون على معدل الأرض معروف، فليس عندنا تصبيخ، فنستخدم نفس المياه الموجودة.
ما قصرت، شكرا جزيلا السيد خضر، يعطيك العافية. Now I would like to call Dr. Ziad Zaidi and the Sayyid Naif Al-Yami on the stage, please. We would like to invite Dr. Thamer Al-Khamis to the stage. Dr. Thamer Al-Khamis to the stage to receive his certificate. Dr. Furqan Tahir from KAUST, please welcome to the stage. Dr. Mohammed Jamil from KAUS, please welcome to the stage. Dr. Awad Ba'agal from Jeddah University, please welcome to the stage. Dr. Sadiq Ibrahim from Jazan University, please welcome to the stage. Engineer Fakhruddin from Digital Petroleum Company, please welcome to the stage. السيد خضر الغامدي من شركة أراك، تفضل على المسرح. So the best award to Dr. Furqan Tahir, please come to the stage. This is for the paper presented today. Thank you very much. Thank you, Dr. Ziad, Mr. Naif. Thank you very much. As we close out day one, I want to thank each of our speakers and all of you for bringing energy and passion to today's discussion. Take a moment to reflect on what you have learned, and we will see you tomorrow for another incredible day of innovation and inspiration. Thank you very much.
Ladies and gentlemen, please take your seats. The session is about to commence.
Good afternoon, all of you. Welcome to the science stage and to our session, which is called Acting on COP Decisions, Advancing High-Resolution Geodata and Facilitating Access to Earth Observation Tools to Achieve National Land Degradation Neutrality Targets. This session is organized by GeoLDN. Geo is the group on Earth observations. We are the land degradation neutrality flagship of GEO. And GeoLDN came to life 2017 at COP13 in China, where UNCCD asked GEO for help in implementing the convention, and GEO responded by setting up GeoLDN. And we take our mandate really seriously. We are happy about a strong custodian agency in the background to support them in reporting and monitoring SDG 1531. Today is about one of the decisions of a previous COP to advance multi-decadal higher resolution data. And we have a very interesting lineup of speakers and experts from the European Space Agency, from JRC, the Joint Research Center of the EU, the China Academy of Sciences, Conservation International, Apacheta. So I will not spend much time with the moderation, and we would like to get started. So the speakers took place here on the panel so that you can get to know them a little bit. But I think for their benefit to see the screen properly, they will move to the audience, and then we take turns one by one. So without much further ado, I would like to start the session with our first speaker. That's Zoltan Santoy. He's a land application scientist from the European Space Agency. Zoltan, welcome. The floor is yours.
You'll have to speak into the microphone?
Yeah.
Okay.
Click on advanced backwards.
Okay, all right. Hey everyone. It's a little well after lunch, so you should be still alive. Good afternoon. My name is Zoltan Santoy. As Ben introduced me, I work for the European Space Agency. My title is actually land application scientist, but within that domain, I actually deal with agriculture, so not necessarily land degradation per se. However, agriculture, water, land degradation kind of comes hands in hands. So what I will do is the first part, I just show you two projects. ESA, we do not only build satellites, and that will be the second part of my presentation, but we also fund a lot of projects to show to the public that actually the Earth observation data or the data with the satellites, what we build provide, is actually useful for various purposes. Here in this case, we are looking at the land degradation. So let's jump into it because I have 10 minutes only. So I will talk about two projects. Both are getting to their ends. So one will be SEN for LDN, as you can guess, Sentinels for land degradation neutrality. So this will be just a short overview. It run to some of my colleagues. And generally how ESA works in terms of projects is that ESA gives the funds based on a winning proposal, and then generally we deal with consortium of companies from ESA member states. So in this case, you see the lineup. Vito from Belgium was or is still the prime, and the additional collaborators or subcontractors. Now, so what about the SAN for LDN projects? So the objectives were basically to develop, demonstrate, and validate a robust Earth observation-based methodology and I was hearing some side discussions. People are talking about the frequency and the spatial resolution of the data. So this project was looking to exploit the high frequency and spatial resolution of using Earth observation data. Another very important point here is, which is actually not bolded, is open and free. So all the data, what is coming from ESA in general, but for this project for sure, is free of charge. So anyone can get it, anyone can deal with it, anyone can use it. And then based on this data, we try to assess land degradation and restoration activities. So that's kind of the lineup, how we did it. So the consortium not only figures that that's what they want to do, they do actually heavy user consultation. And based on that user consultation and the data I just mentioned, they develop algorithms, a possible solution, of course, Earth observation-based solution, and then try to show how we call it through national demonstrators or demonstrations, how useful what we did. So in this case, in this project, we actually deal with 3 national demonstrators. So as you can see, it's kind of hard to see actually, but Colombia, Uganda, and Portugal, where we looked at it. Trying to go to the next slide. Here you go. So what we looked here. So within the project, we looked 2 trends which can be built together to help country reportings. So one of the trends we looked at is land cover. So here, again, very importantly, not only we are using high resolution data, which here I refer to basically the Sentinel-2, but I can also mention Sentinel-1. One is, of course, multispectral optical data, another is radar, but both are at more or less 10-meter spatial resolution. But not only the data here, but also on automated processing, meaning the user himself or herself doesn't necessarily have to deal with heavy computing front of the computer, rather than using a cloud-based solution. And based on that, you develop something, you just run what was developed. So in this case, of course, we are looking at land cover. So Sentinel-2 based land cover for 2018, Sentinel-2 based land cover for 2023. And then we get the transition and the potential degradation through this processing chain. So this was one trend, what we are where we developed a solution within this project. And the other trend was land productivity. So here, basically, similar idea, but we are not looking at land cover. We are looking at land productivity, which we used still Sentinel-2 data, but basically we looked at the biomass increase or decrease over time. And then for the reporting, what we thought that put these 2 together, so to be able to report 15.3.1 as an indicator. So basically what we did is what is called one out, all out procedure. So we put all the land cover and the land trend, land neutrality trend into the algorithm. And basically you get out what is at the end is called one, that you see the last little screenshot, 1OAO, one out, all out output, which actually indicates restoration, restored or degraded areas. We are also looking into another development called continuous sub-indicator, but this is kind of in the research phase. However, the top part is fully developed, so if someone is interested, again, not only the data is there, but the whole procedure, the whole application is there, which you can use just basically off the shelves, free and open. So the main outcomes, so for this, again, using basically Sentinel-2 and ERA5 data, which both are free, and the output is annual very high spatial resolution products. So this was, I think, what I heard here over, in the side discussions. This is something which is really important. People were talking about 500 meter spatial resolution, then some of you talk about 30 meter spatial resolution, but now we are at least at a 10 meter resolution. I will even say a lower number, which is higher resolution, in the next few slides. Another project, so this is the second one we thought to show, it's called World Soils. Here we developed a soil organic carbon monitoring system. Unfortunately, so we call it World Soil, but unfortunately, based on the budget we had, actually what we have is a European soil organic carbon monitoring system. But again, the same story as before, free and open data and free and open processing chain. So whatever ESA develops, since we are an R&D organization, we don't charge for those things. So the data is free and the system is free. This system that we developed is pre-operational, so almost ready to go. And just to explain in 10 seconds why it's not Word. So Europe has a really, really good soil organic carbon ground truth data through the European Commission Lucas initiative. And this is really unmatched. Not in the US, another developed part of the world, but nor in developing countries, such a ground truth database exists. So this is basically, again, proof of concept type of work. As far as we have enough data, we can expand this to a global level. And again, I don't have laser here, I think, but the point is, look at the resolutions for soil organic carbon. Basically, we can go down to a 50 meter spatial resolution. If you are interested, data is available for Europe again. Sorry about that. But again, if data exists, any of you come to me and say, oh, I have data for, I don't know, Kenya, I have data for Saudi Arabia. The system is there, so we can plug it in and run it. So that's shortly, because time is running, that's shortly about the two projects, what we found. And I mentioned earlier that I will be talking about data as well, because at ESA we know that data is everything, of course, for this kind of work what we do here. So what we have, so we have what we call basically at ESA the operational satellites. Of course, all of our satellites are operational, but the point is, and you see the Copernicus Sentinels, what I refer to. This is, of course, a fully funded, fully engaged, well, it's a program, right? I was going to say project, but it's a program, actually. So these satellites are up, flying. By the way, Sentinel-1C, if it tells you anything, is as of 2 days ago, that is up and flying. So please look at it. So we have these families. I say these families because it's not only one satellite. So for Sentinel-1 has 2 satellites up. Sentinel-2 has actually, I think, still 3 flying, but definitely 2 will be there. And for a longer term. So here, where we are looking at trends, this is extremely important, of course. So Sentinel-2 optical, one of the most used sensor or data in the world nowadays, is flying for more or less 10 years now. And it's going to be flying for, I don't even say more or less, for hopefully another 15, 20 years at least. Free and open data, I have to emphasize that again. So this is what is currently flying up operationally. And then we have the expansion missions. I will have the next slide on that, so I'll not spend much time here. And we have the Earth Explorers, which are basically, again, what I don't call operational per se. Of course, they are operational in a sense that they are flying and providing data. but they are not necessarily a long-term commitment, so more like a scientific commitment from ESA. So we build them, we fly them, they're going to fly for 2, 3, 4, 5 years. We get the data, we analyze the usefulness of the data, and actually how it works is if we think that any of these provide data which is necessary, good for the public or private benefits and so on, then we actually go into the next step that some of those we will, well, in a sense, rebuild them or build them in a better form, and they can come back to the Copernicus Sentinel family eventually. So that's kind of the idea behind the Explorers. And I said that I'll talk a little bit more about the expansion missions. So these are what we are looking into to the very near future. You have plenty. CO2 mission, LSTM mission, CHIME, ROSE-L, CIMR, and Crystal. Now, from my perspective, for me, the most important ones are LSTM, CHIME, and ROSE-L. And I think for this audience as well, LSTM will be providing temperature data. CHIME will be providing hyperspectral data. Of course, hyperspectral is super important for land degradation, but also mineral exploitation, for example. And ROSE-L is just another radar system which picks up different signals than the Sentinel-1C. And I see some timing issues here. So only one slide left, I think. And anyone is here, I want to invite you to look at the Integrated Policy Expert Scheme at ESA. So here we are looking for basically policy experts, and I hope that many of you are, to come and stay with us for a certain period of time, from 3 months to 1 year, and help us to work or work with us on your policy and how ESA could support your policy. So there is no application deadline, there is no such a thing. So look at it, please, and I think there is an email, pretty simple, ipes@esa.int. Email us, tell us what you want, why you are interested, and we talk. And we hope to host you. So by the way, I am based almost in Rome, in Italy, in Frascati. So it's not a bad place to come for a few months. So I really encourage you to come and stay with us. And I think that's pretty much it. Thank you very much.
Thank you very much, Zoltan, for this very interesting presentation about sensors, data products, and algorithms to process this data. Congratulations to the very recent launch of the Sentinel-1C. Quite impressive to fill that gap in the Sentinel-1 constellation. Next up, we have Andreas Brink.
Thank you.
Andreas Brink is a Senior Scientific Officer at the JRC, the Joint Research Commission of the European Union. Thank you very much, Andreas, for being here. The floor is yours.
Thank you, Bernd. I take this one. Good. Right. I'm very glad that Zoltan presented before me, because we often work together in terms of research. And very often what we do after research is to take things in operations within Copernicus. And you will see an example here and how it will fit to the CEN4 LDN example. Good. We know about this, the requirements for SDG indicator 15.3.1. The sub-indicators, land cover and land cover change, land productivity, and soil organic carbon. Today, I would like to focus on this one, on the specific land cover and change. And we have heard about improved requirements in terms of spatial resolution between 10 and 100 meters. What you want is a classification, but also a change detection, not just basic annual land cover maps. What we have so far is from Copernicus, we have actually a 100-meter land cover product. Looking at the time frame from 2015 to 2019 at the moment. But why is the ESA CCI mostly used at 300 meters? Because it has a longer time frame. And of course, this is quite critical for the applications we are looking at. So yeah, it makes sense to use this data set as well. But let's dive into what's coming next from our side. So how we move from 100 meter to what is coming up now within Copernicus. And maybe just one slide on the Copernicus land monitoring service. So as you know, may know or maybe not know, Copernicus is not only the Sentinel satellite family as Zoltan just presented, but much more it is about the services. There are 6 different operational services which are all free and open and fully quality controlled and validated. Operational is a really long-term program, and I'm responsible of the land monitoring service. There's a whole series of variables that we process and provide either at pan-European scale or at global scale. So looking at biophysical variables like all the vegetation variables, and then of course the land cover and land cover change. Good, we know land cover is really fundamental layer for many applications. It's really from biodiversity, looking at pressures, at fragmentation, food security in the climate domain, for the climate modeling, for carbon assessment, and of course also for the land degradation applications. As I mentioned, so far we had the 100-meter spatial resolution map produced by Copernicus, 21 discrete land cover classes, but more than that also it had all these fraction layers which are very interesting, from 0 to 100 basically. A user could kind of produce his own legend from this on different variables. Pretty good global accuracy of 80.6%, and of course supports, and it's used by many, many applications. It was really one of the most used products within our service. What is next? So I mentioned ESA research, and here's where we, for example, collaborated very well. There was the World Cover project within ESA producing a 10-meter land cover map at global scale for the year 2020 with the classes which you can read there. So the next step is then to bring research into operations, right? And this is what we are doing right now. So very important is, first of all, is continuity. And this is what we need also in discussions we have here about LDN, about land degradation, desertification, all this. So of course we will continue the 100-meter product from 2015 up to the next years to come. But then we will enhance. So we will take what World Cover did and build on that. So have a global 10-meter resolution land cover map for the next years to come, from 2020 onwards. Improved accuracy compared to World Cover, and certainly compared to our 100-meter maps. That's the aim, very ambitious aim here. But more than that, it's not only a yearly land cover map, but it has very useful, interesting sub-layers, the sub-annual products, and I will come to that in a minute. And in addition, it will have a specific tropical forest layer. Good, and these are the products basically which will be provided to the global community. So not only the land cover and land cover change, a real land cover change, so not only yearly maps, but it's based on probabilities, as Zoltan showed already in his approach. Then, of course, the continuity of the 100-meter products, but then we will have this land surface features and land surface categories. So these two, basically, they serve to build the global land cover map. Land surface features, what are these? These are basically the global mosaic of the Sentinel-2 and Sentinel-1 images produced first at a monthly basis. So consistent for the whole globe, Sentinel-2 analysis-ready data. At the monthly, sooner at the 10 daily or even near real-time availability. And land surface categories are then the first basic, let's say, key classes which we will analyze, and also this at the monthly and even 10-day cycle. So this is the, one example of the land surface features, where we have there included all the different sentinel bands, of course, which flow then into the processing chain. From here, then, we derive this land surface category. So you can see it's 6 categories, of course, improved cloud and cloud shadow mask. Then is woody vegetation, herbaceous vegetation, non-vegetated land, snow and ice, and water. And this globally consistent at the monthly and in future even 10-day level. So I think this really a very interesting sub-layer which can then serve a lot of side products. So it can be used even in addition to the yearly land cover map to see, you know, a 1-year static map, but in addition, you can see the evolutions of woody vegetation, herbaceous, and so on. This is the tropical forest layer, so there will be a specific tree cover density layer and tree cover presence change, also at the annual basis. A very important layer, for example, in the EODR framework. Of course, this will be seamlessly integrated in the global land cover map, so there will be no discrepancy between this forest layer and the global forest layer, of course. Good, and this is where we are right now. So we are analyzing the first global 10%, so this is, let's say, the prototype of it. Selected different areas of interest based on ecoregions, based on different parameters, really to test the system. It's really, as we speak, going on. And so we have this annual land surface features and the land cover map for 2020 for these areas globally, and then the monthly layers as well. So we are reviewing, we are validating, and then really fitting the algorithms for the purpose then to process this at the global level. And this is already my last slide. So the launch of the global land cover forest monitoring product will be at our next Copernicus Land Monitoring Service General Assembly from 20 to 22nd May next year in Krakow, Poland. And I invite you all to either to come in person, of course, but there will be also hybrid options available. And that's already all from my side. Thank you.
Thank you very much, Andreas, for this presentation of the Copernicus services, focusing, of course, on land cover and forest monitoring and building on the sensors and data products introduced by Zoltan earlier. Please keep your questions for the end. I hope we have time for questions and answers at the end. Next up, we have Gabriel Daldigan from Conservation International. He's land system scientist, and he's also one of the co-leads of one of the GeoLDN working groups on data analytics. Welcome, Gabriel. The floor is yours.
Thank you very much, Bernd. Hello, everyone. Good afternoon. My name is Gabriel Antunes Aldegan. I work as the land system scientist at the Moore Center for Science at Conservation International. And I'm going to give a brief presentation today on the efforts that we are doing to bring the data sets, the geospatial data sets that we are producing using Landsat data sets, Landsat imagery for the baseline and progress periods. Back in 2022, we had acknowledgement of the efforts that we have been doing, and also there was a decision at COP22 that, COP15, I'm sorry, in 2022, that invited the Group on Earth Observation LDN flagship to keep the effort that we have been doing, and also to develop multi-decadal high resolution data sets for land surface dating back to the year of 2000. Additionally, the CRIC last year also invited GeoLDN and Conservation International to ensure that the default data are accurate, complete, scientifically reviewed and documented, and where feasible are based on continuously available high-resolution interoperable data products and for land surface, including small island development states. So at Conservation International, we are the developers and maintainers of Trends.Earth, a geospatial analytical tool, which is a plugin for QGIS, so it's an open and free available geospatial analytical tool. And if you are familiar with the LDN and SDG 1531 framework, we have been using MODIS, mostly MODIS scale data sets to cover the world when we talk about land productivity. We have, Andreas just presented on the ESA CCI land cover data set at 300 meters spatial resolution. And we also use the ISRIC soil grids 2.0 at 250 meters spatial resolution representing carbon stocks. But as this invitation highlights, we have to enhance the spatial resolution of these data sets because unfortunately they don't necessarily apply for small island development states. So what we have been doing within this context is to approach a new methodology where we can take advantage of the Landsat family of sensors, Landsat 5, Landsat 7, 8, and 9, which have 30 meter spatial resolution pixel size. So with that, we hope that we're going to bring land productivity, more specifically, that's the effort that we are taking, down to 30 meter spatial resolution, and we could attend the demand from small island development states, so we could understand how vegetation is behaving within those territories. So, okay, seems quite straightforward, but actually if you work with remote sensing, if you work with Landsat data, of course we have major challenges. One of those is that the Landsat imagery does not necessarily have data available for all the small island development states. So when we talk about Landsat 5, for instance, we have a lot of coverage for Europe, for South America, North America, Africa, but not necessarily for for the seeds. Clouds and shadows are also a challenge because they hinder the observation, so we cannot see through them when talking about optical imagery. And one major technical issue that we also have when talking about Landsat 7 is one of the parts of the satellite, of the sensor, actually had a failure back in 2003, just after 1 year or 2 years of the launching of the sensor. So the scan line corrector had an issue, and that hinders also a good observation over all the territory. So here I'm going to give you a sense. So we have Landsat 5 back in which we have data back to 1984, but we can see major gaps when we see this map here on the left-hand side. For Landsat 7, we have a lot of coverage, pretty much the entire world, but given the SLC issue, we have a lot of data that has been compromised. And when we talk about Landsat 8 and also 9, we have a lot of good coverage. But if you pay attention to the slide there, to the figure there, it just starts in 2013. So if we go back to 2000, if we need to go back to 2000, we have major gaps that we need to account for. So I talked about the Landsat 7 issue. So this is a scene, a raw scene from Landsat 7 ETM+. And these black lines, black stripes that we see is the issue that the scan line corrector failure brings to us. So we have coverage, but we have a lot of gaps in between the good pixels as well. And another challenge that we have, obviously, is quite well known, is when we have mainly in tropical areas, but not necessarily only in tropical areas, we have cloud shadows when we're talking about optical imagery. Okay, so we talked about the task and the challenges, but what are the solutions that we are exploring right now? So I'm super glad that we have Professor Lee and Cesar Garcia here because they're going to talk about the first solution here, the 30-meter high LPD exercise that they're doing at the CBUS in China. And at CI, and in collaboration with GeoLDN, the Group on Earth Observation Land Degradation Neutrality Flagship, and other partners, we are exploring also an alternative method for the effort to bring the spatial resolution of land productivity dynamics layers back to 2000 to 2015, so we could produce annual steps from 2000 to 2015, so we could assess land productivity trends, state and performance metrics for the baseline, but also, and then after 2015, have data sets for assessing progress towards the land degradation neutrality efforts. So here is an example. So this is EVI2, the two-band version of Enhanced Vegetation Index. This is for Belize, not necessarily a small island development state, but Belize is part of the Global Dialogue Forum, and we kindly produced the data set for them as well so we could understand. So we have, this is for the year of 2023, so mainly taking advantage of Landsat 8 and 9. And we have a lot of good coverage, and we could produce the land productivity dynamics for the entire country and also the islands that are part of the country. But then, here on the left-hand side, what we have is Fiji, or this is a slide for Fiji, and then we can see also EVI effort. But then when we just take the good observations, we can see that there's a lot of gaps, observation gaps. So what we need to do is to apply statistical methods to perform linear regressions and interpolation, actually, not regression, interpolation, spatial temporal interpolation, so we could fill those gaps and actually have fully coverage or aim for fully coverage of the archipelago. And here, I'm not sure if I'm going to be able to play this, but this is a video actually, which ideally would go from 2000 to 2023, showing the effort, the mosaic for Belize. Oh yeah, there we go. So here we can see there's still this, I need to say, I need to stress this. This is a pilot. We are right now piloting for Belize, Barbados, and Santa Lucia, and also in Fiji. And then the idea is that we could take the lessons learned with this exercise, share with Professor Lee, Cesar Garcia, and other scientists and practitioners exploring solutions for this. So if you have any solutions, please come talk to us afterwards. And I'm so glad that Zoltan also presented on Sentinel-4 LDN, because as at Conservation International, we are a collaborator, partner of this project. So, but this is moving forward. So what I just presented was Landsat scale, so 30 meters spatial resolution. So we could go back to 2000 and cover the entire time series necessary for the UNCCD land degradation neutrality framework. But moving forward, we are also exploring the 10-meter spatial resolution data sets that Zoltan just presented. So here, for instance, is just a snapshot of the app that Vito Remote Sensing put together. And this is a European Space Agency funded project. And here we can see that we have 6 layers representing land cover, land productivity. But of course, Sentinel-1, Sentinel-2, A and B, were launched back in 2015 and 2017, so we have full coverage of the world starting in 2018. So these not address the issue or the challenge to assess the baseline starting in 2000. This is pretty much what I had to talk, and as I said, so if you have any contributions to the challenge that we are facing, please come to talk to us afterwards. Thanks, Bernd. Thanks, everyone.
Thank you very much, Gabriel, for talking about the challenges in coming up with global data products which address the needs of the countries, especially smaller countries and small island developing states, and also for presenting a solution we are currently working on, or you are currently working on. And thank you also for all the speakers up to now for keeping time. This helps us a lot. The last presentation we have is a joint presentation. We have Professor Lee. He's a professor at the International Research Center for Big Data at the Chinese Academy of Sciences. And also we have Cesar Garcia, who has done a lot of work on land degradation neutrality for various international organizations. He's also one of the co-chairs of the Working Group 4 of GeoLDN. Welcome, Cesar.
Okay, thank you. Okay, yeah, I'm representing myself and Professor Lee. I hope I do a good job. Okay, we thought, okay, we will talk, we are doing things on land cover, on land productivity. Since short time, we think to present some of the things we are doing on the land productivity map. I will try to add some new visions to this or to what we've been doing. I mean, since the last time we started playing with this data, we realized that with the same data, you can get very different results depending on the decisions you make on how you analyze the data, no? There are many ways to calculate a trend, to calculate different type of metrics to the data that are statistically okay, and each of these methods of decision, if you start here, there with the year, will produce a different map. Also, some part of the land productivity models that all of the model normally use, one of the metrics is called the state. There are many possible ways to get this. So there are decisions to make when you are analyzing the data. If you go with this methodology recommended by this guy or by this other guy or by this guy, and all are possible, but any decision you make will land you in a very different map. If you don't make any decision, somebody else will be taking decision for you, and you will land in some map of this. So yeah, something worth exploring a bit. So this was our motivation at the beginning that came from many projects that we have in many different countries, and we thought that often all of these global products didn't fit in the national reality. Every country we were to work, the same thing. No, this doesn't work, this doesn't work. Not only land productivity dynamic, land cover, all the global maps have some sort of thing here and there. That's why they are global maps. And so this motivated our team at FAO and WOCA to say, okay, let's find a solution. Let's do a model that we can use that combines we get the 5 categories. We have a flexible approach where the users can parameterize, can adapt it to their territories. We use open code, fair data, so people can go modify the model. The data is available easily. The code is available easily, and you can simply go, click, and try to improve the model, or at least make your own decisions about it. So that's when we started creating the land productivity dynamic from FAO WOCAT. So it's basically a script in Google Engine. You go to the link, you press run, everything is there, the data, the code, you get the map. If you don't like it, there is a code, change it. And that's kind of the initial version 1 that we did. We went very okay with this. This was presented in the launch story that was launched last week. Many examples for many countries using this on Bhutan, Bosnia-Herzegovina, Colombia, Ecuador, Panama, Turkey. We did a regional workshop to exchange with the countries. And it also was presented in the Creek in Samarkand, where some decisions were made to improve on this further and scale this up. And that's something we are trying to do. So our point of view here is a bit that we need to find a place where the bottom-up meets this top-down approach. So we have our models, our algorithms, our data. We can produce a global map, but we need your input. We need the input of the local user of the country, the knowledge, maybe data, maybe expert knowledge, to put into this, so we got a more fine-tuned product with the best science that we can find and the best local knowledge that we can get. So our idea goes to this, to develop these country-owned Earth observation products. We are thinking of actionable data, so we want the map to represent you, to have ownership, to be co-developed, so you can make decisions on this map. Many times, yeah, maps are just there goes to the reporting. Nationally, they are not used for anything. You are not making decisions at the country level with these maps because they don't fit your bill. We are trying to change that. So we are also trying to do fit-for-purpose tools to help you with the decision making and understanding a bit how to mix this data, mix land degradation with biodiversity and climate change, so you have a better picture of what is going on. This is mostly what we cover. It's quite a lot, but let's go back to the land productivity trend, land productivity dynamic map. So we have a new version where we also try SAVI, EVI, NDVI, SPI. We are playing with countries that are quite diverse, so maybe in one part of the country you have a dry land, and in another country you have a tropical forest. So the same model will not work everywhere. We know that by fact, and we need to include expert knowledge and choose the best available data set. This is very important for seeds, but it's also very important for hyper-arid areas, like we are here now in Saudi Arabia. All of the global products don't fit the bill because it's a very particular place with very low cover vegetation, so we need higher resolution and new methods to that. I will not extend on this, but different indexes theoretically are better for different type of ecosystems. Yeah, theory is always nice. What you need to do is to prove it, is to try to run this. We divided here Ecuador. This was also part of a side event where we did subnational regions. And we saw, okay, how is the difference in the Amazonia compared to the highlands, compared to the dry forest, which is the index that works best at each different location. Not only that, but you know, you have a signal, a time series. You can filter that many ways. You can try to remove clouds with different filters. You can use precipitation data to see the decoupling on the trends of NDVI from climate. Because sometimes you want to know, okay, I have a negative trend in productivity, but it's also raining less. But if I have a negative trend and it's raining more, yeah, that means maybe I'm doing something wrong here. So there are a few options, and as I said before, different places work differently. Especially on seeds, we have this problem of first resolution, and then this, for example, shows the central part of Grenada that being as declining or degraded. These are the national park. It's the most preserved part of the island, but it's very, very cloudy. So what you get is a lot of cloud interference, and if you use just the NDVI like that from MODIS, you hit all the clouds and you get a negative trend. But if you put some of the different filters that we can use, then you get a more realistic map. The only way to do that is go there, work with the people, find a solution, have a look, understand what is going on, and solve the problem. And that is what we are trying to do also with these partnerships that we are having with especially CIVAS and Apachita. CIVAS is developing the high-resolution LPD. This is a mixture between the Landsat data and that is harmonized with some MODIS data. So when there is a lot of gaps, like Gabriel was showing, there are some islands that is just very cloudy, well, we have more data into the mix. And we can see here one of the images we have. So this is a part in one of the Caribbean islands where you can see the cultivated plots, how it looks with our FAO WOCAT model and 250 resolution, and how does it look at 30-meter resolution. You can detect the edges of the field, and you can more detailedly analyze the different producers maybe are having some negative or positive trend, and you can try to understand why this is happening. So the high resolution is also fully compatible with our previous product. And we are also trying to build or create new products for seeds and hyper-arid countries, so it's easier for you to do this bottom-up, top-down approach. So this is one of the applications we are doing where you just can choose different ways to analyze, parameterize the model. You will run it, and you will have your land productivity map in real time. If you see something odd, you can try different things, different indexes, and this happens on real time. So after you're done and you're happy with your parameter, you go to TransEarth, you get your final map to the reporting. That's one of the ideas we are working on, and we already can do this for the whole world. Then this is just to show you some other examples, how it looks like for many islands if you have 200-meter resolution and 30-meter resolution. And important to say what Gabriel was mentioning, the compatibility from 2000 to now, we need to have our baselines, and we need to have this compatibility going on. Yeah, these just are simple examples, and these are the products that we have so far. going from 2001 or 2000, depending which one, to 2023. And we also have different 30-meter resolution options. So by the next time, I mean, CI is doing one different methodology, and we have already 2 more. So there will be 3 options. We never know what is going to work in your countries, but at least we want to give you all the possible things for you to get the better map, the best map that you can. This is something that we think, I mean, for seeds especially, but this is not only for seeds. If we see, for example, hyper-arid areas, the representation we get with the high-resolution LPD from CBAS at 30 meters is much better than the one we were getting only with the MODIs. So it improves also in some of the arid areas. And even if you go to these places like Argentina, we have very big plots. So you may say we don't need high resolution. But look at the shape of the plot and in this 250 and in 30 meters. The products are quite similar. But then you can basically see, okay, what are these guys doing there that is getting them more productivity over time, and what are those guys doing there that are getting less productivity over time? So this resolution not only improves in seeds and hyper-arid country, but it's something that we could use, and we already have a global product for this in all the world. Thank you.
Thank you so much, Cesar. You covered quite a lot of ground in your presentation, and the sentence I will keep with me is where top-down meets bottom-up, so where the best science available meets the local knowledge, because that creates the products which are reliable for and which the countries trust. So that will also lead to a situation where they are willing to base decisions on those data sets. Could I invite all the speakers back to the stage? We have a few minutes for question and answers, and while you think about your questions, let me say there's a chance. I mean, the green zone of the COP is supposed to bring the blue zone and the negotiations or make it available to a wider public, and that's what we're trying to do here on the science stage. And if you're interested to follow the discussion, you have the chance later on in the afternoon in the Blue Zone. We have two events, so you have to decide. Some of the speakers will go to an event organized in the China Pavilion about big data. Other speakers will be available at an event in MET07. Is that correct, Andreas? MET07 in the Blue Zone, leveraging high-resolution data products. So you're most welcome. If you have Blue Zone access, to follow us into the Blue Zone and continue the discussion with the speakers. So thank you very much again to this panel, and I'm really impressed that we have a few minutes left for discussion, and I hope there are questions in the audience. Do we have a roving mic maybe? Can I steal one mic from you? No. Oh, okay, we have. So, do I see questions? Yes, Eunice.
Thank you very much. My name is Eunice Wangoi. I'm from the GLDN Help Desk, where we have been supporting countries to leverage the GLDN toolbox for monitoring land degradation at country level. Let me start by appreciating the presentation on the new land cover map at 10 meters, which is a real game changer, because from the products we've been receiving from the land degradation neutrality, it was at 100 meters, but let me show appreciation that right now we have the 10-meter global product that is coming from the Sentinel images that is going to improve the accuracy of land degradation at national level. My question goes to the last speaker on the land productivity dynamics. And there has been a confusion among the three methodologies that are being used to compute land productivity. And you have slightly mentioned it in your presentation. I'm curious to know whether there are plans to either merge or maybe propose just one methodology for land productivity assessment to avoid creating confusion, or where we still need to maintain the three different methodology? What is just the plan so that we don't end up maybe confusing the policymaker on the trends, because they really show very different results? Thank you very much.
Okay. Gabriel, you want to? I was trying to escape. I almost did. Thank you, Eunice. No, actually, we are not thinking on reducing the difficulty of the thing, because that is actually the point. I mean, if I give you one map and it's the map that you don't like, will you keep that map? No. So, I mean, you want to do your own map. So that's what we are trying to do here. I mean, we are all making an effort on having a global map, which is kind of nonsense in this situation. As we see, all the different maps are different in different regions. And what we have seen is that different countries opt for different options depending on their land. So what we need to do perhaps is invest more time in capacity development, so the local technical team can choose which is the best map for their country and only give that to the decision maker. But that should be a technical process. That way we do the reporting. It's not just one person deciding. It's a participatory process. It's a workshop where you need to have different ministries, different organizations, universities involved in the production of the data sets. UNCCD gives you some data in case you don't have anything, but the idea is that you go beyond that. You go to tier 2, you go to tier 3, you get a better map. And when you are doing a map, there will be always these crazy options. And it's not only land productivity, no? Now there are a few sets of 30-meter land cover that we are considering as default for seats that cover 2000 to 2020, 2022. So, and when you look at them, especially in the islands, they are very different, but who's going to choose which one is the right one? I will not.
If I can complement, thank you so much, Cesar, and thanks for the invitation also to contribute to the answer. Thanks, Eunice, for the question. The point is exactly that, as Cesar mentioned. We don't want to make the decision. It's for the users, for the countries to make the decision on which data set is best represent land productivity and land cover within their territory. And that doesn't mean that the best one is the one that shows the least land degradation. That's not the point. We need to be transparent. We need to be take very informative decisions on those, but we cannot take the responsibility of offering just one solution. The solution, we as data providers, and data and tools providers, the idea is to produce options to the users, to the countries, and then the specialists. I'm a specialist in Brazil. We have specialists in Europe, in China, in Argentina, but we cannot cover the entire world. So the point is exactly that. So it's up to the countries to decide on which data set is best representing. And not only for one data set for the entire country. In Brazil, for instance, one data set is going to be very suitable for the Amazon, but completely different for the Savannah. So yeah, that's the point.
May I just add on very quickly on this? Yes. I fully agree with my colleagues on this. This is also a bit kind of science democracy, I would say, that we have different options. It's a lot about communicating this also to the users. Is to communicate also uncertainties on our various products, and then communicate the options, the different ways, methodologies, and the products basically to the users. But then leave the options open.
And if there's another section, I would actually go back to the good old accuracy assessment of any kind of remote sensing products. So I'm not sure what Cesar was referring, that the user or a local expert will choose the map based on. From an Earth observation data perspective, you should look at that product or products you provide from the accuracy assessment part. So if you do not do that, you will not be able to actually say which map is better or which map is worse. Thank you.
So I want to speak a few words about the land productivity. You know, the CISA introduced about the 3 measures. I think maybe you would say the results are obviously different in some of the countries. But if you take a look at the definition of the different products, you will find it's different. Some maps is based on long-term change the map, and some map is based the long-term with the local net scaling. It's different based from the definition, I think, these measures. So which one is better for you? I think it would depend on the user's selection, I think. Besides this, I want to emphasize the work of the CBAS. You know, in the 2020, we published a paper and produced a new LPD product, which is based on the different indicators. We will check the consistency between the different indicators. We use the 4 indicators to check the consistency. If one place all the 4 indicators show the same trend, we would take a label as the high confidence levels from the user's perspective. I think maybe now this product you could use from the United Nations Biodiversity Lab on the internet. I think maybe it's useful for the users as well. Thank you.
Thank you very much. Excellent question, which led to a good debate here. And it's really, of course, I mean, it's straight to the point. And we heard it's a lot about capacities to make sense out of the data, and also about communication. I'm afraid we are almost out of time. I don't know, we have maybe time for one more question if there is.
Hello, my name is Anna Andreas. I work as a lecturer at the University of Surrey, UK. And my question is about the calibration data for the land cover. So can you expand on the calibration and then the validation, if you're using the same data sets or, you know, around that? Thank you.
So, yeah, very, very quick on this. There's a very intense training data which is collected for this global land cover map, which in future will be also shared to the community so that, you know, others can replicate, can tailor it for their needs. So this is a critical step in any model, let's say, or in any neural network, how it is, or what it's based on. And then the validation is absolutely critical. Of course, these are 2 completely different data sets. It's made in an independent way. And it's done on the global level, of course, but also on a continental and regional level overall, but then also class specific. So, and this is very important, will be communicated, of course, to the users.
Just to understand how important the training and validation data, might be able to ask Andreas, but you know, it's hard to say a number, but a large chunk of a project in terms of budget goes there. A lot more than, of course, I just mentioned free and open data, and that's what the Copernicus land cover is based on. And then you deal with cloud computing. So actually, and generally, half or even a larger part of a budget will go to ground data collection, both training and validation data. As you know, garbage in, garbage out. So this is super important. And I can talk behalf of ESA, but I know a little bit of what Andreas is doing. We are definitely very, very strict on that data, and we always release at least the training data part for sure. Thank you.
Thank you very much. I think we have to cut the discussion short here, but the speakers will be around afterwards, maybe for questions. Thank you very much again to all the speakers. I think it was a very good session. Thank you for your attention and for your interest. And as I said, the discussion continues in the Blue Zone at 6 p.m. in 2 different events. You're most welcome to join. Thank you.
session on the video?
No, I didn't. So it's already out there?
Okay, good. Somebody sent me a small section.
we're gonna get started now.
Yeah, why not?
Okay, good.
We go
Yes.
from here or from there?
No, go ahead.
It's up to you. You're the boss. Okay.
Go ahead. So we're not mic'd for anything, so I guess we use. Okay.
السلام عليكم. السيشن حقنا حنبدأ هنا اليوم فنتوكل على الله سبحانه وتعالى. Good evening everyone. I'm very happy to see all of you here. Welcome to the Science, Technology and Innovation Day at COP16 Riyadh, Saudi Arabia. It's an honor to be with such a dedicated people who care about our planet. Today, we come together to talk about a very important topic, taking care of our land. Our theme is our land, our future. This year, we also celebrate the 30th anniversary of the United Nations Convention to Combat Desertification. It's a great time to renew our pledge to the US science and innovation to protect our land. We will have a special discussion called From Degradation to Restoration, the power and the impact of land governance in community across the globe, not only here in Saudi Arabia, but all over the world. And here we will learn how to smart land management can help with the climate change and protect diversity. I encourage all of you to think about the goals we want to achieve today. By the end of our session, we are hoping to understand how good land governance can not only fix environmental problems, but also highlight successful projects led by community. Before we begin our discussion, it is an honor to introduce our moderator for the panel, Dr. Muhammad. In Africa, they call it Dr. Mamadou Baro. He's a professor and the director of the Bureau of Anthropology in Applied Research at the University of Arizona. And his expertise will guide us toward an impactful outcomes as we navigate today's dialogue. Thank you for being here, and I look forward to our discussion.
Thank you very much. I'm really very excited and happy to be here in Saudi Arabia. Bismillah ar-Rahman ar-Rahim. Alhamdulillahi Rabbil Alameen. This topic is very important, and we are here to really come up with some kind of actions, in terms of the crisis related to land governance, land tenure issues, the importance of understanding also collaboration and cooperation between nation states to deal with the problems that the world is going through right now. So ladies and gentlemen, distinguished delegates and esteemed colleagues, it is both an honor and a profound responsibility to address this panel at the 16th conference of the parties to the United Nations Convention to Combat Desertification. Today, we convene at a pivotal moment, not only for policy, but also for humanity collective relationship with land. Land is very important. Even in the Holy Quran, there are many verses about land. Land is a place where we get our food. Land is a place where we get our water. Okay? Land also is a place where we socialize as human beings. So it's really very crucial that we take good care of that shared resource, which is land. Now, when it comes to land, it is important also to realize the importance of good governance. Okay? land governance. And I want to talk a little bit about the invisible foundation of land health. We talk about health for human beings, but we also need to talk about health for land. If the land is not healthy, human beings also won't be healthy. So in addressing this crisis, governance emerges as a critical level, often unseen but profoundly impactful. Land governance involves the formal and informal systems through which rights, responsibilities, and decision-making processes regarding land use are taken. It is the thread that connects the local to the global, and the individual to the collective, the past to the future. Effective land governance has the potential to empower marginalized communities, protect biodiversity, and safeguard climate stability. So good governance of land is very important. Conversely, weak or inequitable land governance systems often amplify degradation, displacement, and conflict. And we see a lot of conflicts around the world today in terms of land and land issues. The stake could not be higher today. And Saudi Arabia is playing an important role in getting all the parties about understanding the issue, but also coming with a common understanding and also solutions to this challenge. Yet, we are also inspired by stories of resilience. So resilience is very important, making sure that not only we go through shocks, crisis, but being able to recover from it. Like a boxer, you fight, you knock down, but you don't stay down. You get up, and you get even better, and then you win the fight. So in a way, also resilience plays an important role in all this. Now, quickly, I want to talk about the role of policy and multilateral collaboration. The UNCCD, the Saudi government, and multilateral frameworks play a crucial role in fostering dialogue, setting targets, and mobilizing resources. However, policies must be more than declarations, just talks and on paper. They must translate into action that is localized, inclusive, and equitable. This means investing in capacity building for communities, making communities resilient. When you talk about resilience, it's important to understand also the need to make people and communities resilient, and ensuring the representation of marginalized groups in decision-making processes, and strengthening legal frameworks to protect against land grabbing and unsustainable exploitation of land. Things that is not sustainable, they're not going to last forever, that will destroy the environment, are things we must avoid. So in Saudi Arabia, with the help of our colleagues here at the University of Arizona, who has a long tradition of collaboration with Saudi Arabia, we are to call for action. As we look toward solution, let us remember that the restoration is not merely a technical challenge. And my colleague here is going to talk about that. He has an interesting insight since yesterday about that, but I will let him talk about it. It is also a political and a moral imperative. So that's very, very important for us to understand. So we as policy makers, researchers, advocates, community leaders, all stakeholders basically must remember that important element. So in closing, I invite each of you to reflect on the interconnectedness of the challenges we face today. The big word is crisis. But sometimes in crisis, you have opportunities to make a big difference. So we need to also make sure that we do that. So land degradation knows no boundaries. When it comes to land degradation, we're not talking about nation state. And neither should our effort also to combat it. So in combating land degradation, we need to get united, okay? And I think also here what is interesting is the leadership that Saudi Arabia is taking in that direction. So without going further, I just would like to introduce our speakers here and also tell you the order of the presentations. And we are really having here people who think out of the box in trying actually to make sure we find sustainable solutions, sometimes it's important to think out of the box. And these ideas are really innovative ideas that you're going to be hearing from the panel today. First of all, we have Dr. Turki Faisal Al-Rashid, who's an adjunct professor at the Department of Agricultural and Biosystem Engineering, College of Agriculture and Life Science from the University of Arizona. And also, he will be talking today about the role of social agriculture as an economical methodology for avoiding land degradation and achieving. He has very interesting ideas. Many of those ideas are in this book that he published. It's called Agricultural Development Strategies, the Saudi Experience, that I would strongly advise you to get and read it carefully. And also, we have in our panel Dr. Rod Wing, who's the director and professor, Center for Desert Agriculture, King Abdullah University of Science and Technology, KAUST. He's going to talk about the use of Saudi native plant genetics to address land degradation on the Arabian Peninsula. So that's very interesting. It's a case study, successful one, with a lot of interesting lessons that can be applied to other parts of the world. We have also our colleague Shafi, who's going to be talking about, he's the head of an interesting organization. He is a young man who actually developed interesting ideas, innovative one in terms of applications and to help resolve some of the issues that many countries in the Sahel, countries are confronted with. And I will let him, the time also to explain to you. And then we have also Dr. Kevin Fitzsimon, who is from the University of Arizona, who is very involved in interesting innovations in agriculture in general, also works extensively in Africa and also in America. So we have a wonderful panel today to address these issues. So we're going to start with you, Rod, to tell us about your experience.
All right, thank you very much. Okay, I didn't know I was up first, so
You're always first.
I'm always first. Okay, good. Okay, so my name's Rod Wing. I'm a professor at KAUST. I've lived in Saudi Arabia now for about 6 years, and I also am on a leave of absence from the University of Arizona in the School of Plant Sciences. At KAUST, I was the director for the Center of Desert Agriculture, and then they closed all the centers at KAUST and have reorganized now, so we have a new center on sustainable food security. So I'm here today to discuss some of the work that we're doing in the area of combating desertification, and I'm going to talk about two topics. One is when I first came here, we met with folks from the national MIWAS. MIWAS is the Ministry of the Water, Environment, and Agriculture. They have a center called the National Center for NCVC, National Center for Vegetation Cover and Combating Desertification. And during that meeting, we learned many things about their mandate. One is they're responsible for managing and preserving almost a third of the country's terrestrial landscape, which that's a huge mandate. The other one is that they're involved within this 1/3 of the country, also developing 500 national parks, which is very exciting. So during our conversations, we asked ourselves, well, what can we do to help in the preservation of this large land, 1/3 of the country? And we came up with a couple of concepts. One is called the KSA, Kingdom of Saudi Arabia, Native Genome Project. And the other one is to the development of experiment stations, similar to what we have in the United States on developing areas that can be used to develop new technologies in the field to help combat desertification. So the KSA Native Genome Project, this is actually being led. The face of the project is Nahid Mohammed, who's in the audience right here. You could say that. She's my my first postdoc at KAUST, and she's also a native Saudi Arabian. The Native Genome Project is a project where we're essentially interrogating terrestrial ecosystems. So we'll take a native plant species, sequence its genome, understand its sequence its microbiome, understand its root architecture, its metabolic profile, and the soil atlas around it, and also its microbiome profile. So we had a pilot project to test 15 terrestrial ecosystems, native ecosystems. A couple of these terrestrial ecosystems as examples would be Ziziphus spinocrista. This is it's a native tree that can tolerate salt water, and this is where the cedar honey comes from. This is the crown of Christ. And another example is a plant called Salvadora persica. And the local name for this is arak or miswak, which is essentially the Saudi toothbrush. If you're here and you get a chance to try it, it's pretty amazing. The Saudi Salvador persica is a magical plant in that it anchors the desert floor. You can grow it with salt water, but at the same time, it also makes a berry, an edible berry, that you can that's highly nutritious. So one of our targets is to be able to domesticate this plant. So we're essentially growing the plant in the desert. It's actually combating desertification, making this extensive root system, watering it with salt water, but producing tons and tons of berries. So we can actually buy these in the supermarket rather than going to buying blueberries from Ecuador or Peru that have flown all halfway around the world. So the Native Genome Project, so we started out with these 15 systems, terrestrial ecosystems, and we've completed this project. The manuscript is under preparation, and now the Prince Mohammed bin Salman announced the concept of the Saudi Green Initiative to plant 10 billion trees. So KAUST, working with the National Center for Vegetation Cover, have come up with a list of 300 native species that are targets for greening the country. So now we're working to apply this Native Genome Project on these 300 species. And so, what can you really do with a genome? Okay, so for example, again, the Salvadora, the idea is we have a reference genome sequence, and then the next thing we do is resequence Salvador across its species range in Saudi Arabia, and then use that information to understand the genetic diversity of the species in the country, and to see if there's any bottlenecks, to see if there's any loss of biodiversity, or there's quite a bit of diversity, and try to preserve that, to conserve that as a very important plant for combating desertification. So it's an exciting project. We've been able to, it includes three other KAUST PIs, Ikram Balou, who's doing the root and leaf development, Salim Al-Bibi, who's doing the metabolic profiling, and Heribert Hurt and Magid Saad, who are doing the microbiome work. So it's a team effort at KAUST, and it's a really exciting project, and it's allowed me to actually see a lot of the country and learn about the environment. And KAUST is, Saudi Arabia is not just desert. There's lots of biodiversity in the country. And I think one of the main biodiversity hotspots is in southwest Saudi Arabia, in the Jazan area, where there's lots and lots of biodiversity there, but there's quite a bit distributed around the country. So the other question that we're trying to address again is this idea of, you know, how can we make an impact on the Kingdom of Saudi Arabia to preserve biodiversity and be able to green the country better. So we have also recently opened a brand new experiment station in Saudi Arabia near Kaust. The experiment station is called the Wadi Khadid Experiment Station. And this is, again, another collaboration with NCVC. They have provided 300, they found a parcel of about 350 hectares of land about 20 minutes from Kaust, and that's going to be the Wadi Khadid National Park. Within the national park is the Wadi Khadid Experiment Station. So we just recently opened this facility up, and right now we've planted, there's a shade house, there's plans to develop greenhouse facilities, and we've recently planted 1,500 native species and are doing different soil amendments, different irrigation amendments, so on and so forth. And this experiment station is meant to be a site for scientists throughout Saudi Arabia to test their technologies for combating desertification in a hot and humid environment of Jeddah, as well as to bring in commercial entities who want to test their products and their IP out to demonstrate to NCVC how they can actually make a contribution to combating desertification. And much of this work is also done in collaboration with the University of Arizona. We're basically a similar latitude around the world, and so this is also a very exciting opportunity. And this is considered one of the first, if not the first, experiment station in Saudi Arabia designed this way. And this is modeled after the land-grant universities in the United States, where like the University of Arizona is the land-grant university for Arizona, and they have experiment stations that are located where the action is, where the farmers are, where the landscape restoration people are, to teach and test and develop new and innovative concepts and ideas related to agriculture and landscape restoration. So I think with that, I'll just end and just say that it's very exciting to work on this project, and the potential is huge. And one of the long-term goals is to really train the next generation of ecological stewards in Saudi Arabia, and that's very exciting. And Nahed Mohammed is the leader in that area, and we're excited that she's serving as a role model, a female role model in this nation to promote ecological stewardship. So, thank you very much.
Thank you very much, Rod. This is really exciting and interesting to stick with Saudi Arabia, because a lot of interesting things are happening that we are seeing since we arrived here. We're going to have Dr. Turki share also his experience, just so that way we have, with Saudi Arabia, and then we're going to move to Africa after that. Over to you.
السلام عليكم. كم واحد من الحضور يعرف عن social agriculture، الزراعة الاجتماعية؟ Anyone؟ الزراعة الاجتماعية؟ أوكي. إذا كان أحد من الحضور يتوقع أنه الزراعة هي فلاحة وزراعة وإنتاج، أقول له أخي الكريم، سيدتي الكريمة، سيدتي الفاضلة، أنتم غلطانين. الزراعة ليست إنتاج فقط، الزراعة هي سياسة، هي تحقيق الأمن القومي للدولة. Good evening, everyone. Thank you for being here. Today, I'll explore social agriculture as a sustainable strategy. I'll try to be quick, so you will have time, you will have time for the Q&A that might be more interactive rather than just we blah, blah, blah talk and you listen. So, promoting ecological restoration, let's discover innovative solutions together for thriving environmental for generation to come. This session focuses on the importance of working together. It takes two to tango. There is no one hand could clap by itself. We need to work together in order to achieve our goals. To combat land degradation in dry area where environmental issue put people's life at risk. Social agriculture is an approach that help communities become stronger, improve food security, enhance national security, and support sustainable practice. This strategy enables local people to restore their land and adapt to the impact of climate change. I'll give you some background about what I'm trying to say here. Saudi Arabia, many people think the relationship between the Saudi government and the US government started because of oil. The fact is, the meeting that took place between King Abdulaziz and President Roosevelt in 1945, they did not mention the word oil. All what they talked about is water security and food security to help the national security of the country and to develop the rural area. Then they made a deal which will be Saudi government, US government, Aramco as a company, the University of Arizona, and the University of Texas. Things doesn't happen coincidentally. I went to the University of Arizona. The Minister of Agriculture who created the agriculture boom together with King Fahd, Dr. Abdurrahman al-Sheikh, he went to the University of Texas. The Saudi government covered all expenses, focusing on water management and food security that have developed Al-Kharj, which is only 70 kilometers away from Riyadh. And in the process of creating or writing my book that I'm doing now, the food security and water security in Saudi Arabia and the Arab world, majority of the people, in fact, 35% strongly agree and 33% they do agree the important roles of government to achieve such policies. Food security is a national security. Food security is deeply intertwined with national security, as chronic hunger poses a significant threat to individual, government, society, and even the integrities of the national border. To achieve true food security, we need capable and effective governance that recognize the political dimension of agriculture development. Agriculture requires a lot of politics. It's like playing chess. You cannot just say we're going to do agriculture and that's it. There is a lot of aspect to it. Unfortunately, for the last 30 years when I've been talking about it, nobody listened to it. But now they have changed. Why? Because of the food crisis in 2007, 2008, and now it's very clear. Weaponizing food, weaponizing water, weaponizing access to energy. I have a hypothetical question to everybody. If you analyze a 1 kilo of wheat, if you analyze it, you will find 12% protein, 88% politics. Now you might agree with that or disagree with that, but what I'm trying to say is wheat is politics. Social agriculture, cultivating resilience in the arid land. I'll share with you my experience. What is social agriculture? Why did I get involved with social agriculture? Back in 1995, I was invited to the State of the World Forum in San Francisco. It was part of the Gorbachev Foundation. He gathered many world leaders in all aspects of the society. And I have met with Dr. Muhammad Yunus. As you could see, he have built microcredit, and now he is the president of Bangladesh. Saudi Arabia, as I said, they have started the agriculture project in 1940 with the help of the US government, Aramco, University of Arizona, University of Texas, and they have built Al-Kharj. In fact, a year later, the Crown Prince, which is King Saud then, he flew to Arizona and he flew to Texas, and almost a year later, which is in 1948, that one is the establishment of the Al-Kharj project. What is social agriculture? Social agriculture combines social value with farming practice. This approach is more than just growing food. It fosters social connection to help build strong community, encouraging collaboration, sharing knowledge, using sustainable methods. Social agriculture improve food security, support environmental restoration, and strengthen the country's national security. On a survey I made about the importance of social agriculture, nearly 40% strongly agree, and nearly 40% agree. So it's about 80% they strongly agree and agree. As I said, wheat is 12%, protein 88%. Politics, I've asked this question. I asked this hypothetical question. I was really surprised. I thought I was the only one think that. 60% of the sample strongly agree, 32% they agree. So we got 92% agree with that hypothesis. So before I was a little bit shaky to talk about it, but now I have more confidence to put my argument forward. Why social agriculture is important? It's very important for several reasons. It gives both men, women, farmer in the village, number one, any guess? It gives them access to new ideas, networking. It gives especially the disadvantaged background, the support, and the dealing with land degradation, dry region. Social agriculture offer a way to restore those land while also improving people's life. One of the major problems we are facing worldwide now, because of the cutthroat capitalism, أسميها الرأسمالية المتوحشة, is the inequality. A handful of people, less than a handful of people, they own more than half of the wealth of the world. So that is a problem. We need to lower that gap as much as we can. Then I put a question, why people migrate? Why the city became so big and rural area are being deserted? People are moving from rural area into a big city. A lot of people think because it's improved their life standard, improved their income, better social environment, better health care, and better education. When social agriculture is important? It's important all the time. But during crisis, that's really what matters, such as drought, natural disaster, diseases, outbreak. In those difficult times, building community unit and teamwork help with recovery and resilience. Before, when we talk about drought, we talk about problems, we were talking about national. Now, when we had COVID, one part of the country maybe have abandoned food production, but the other side don't have any supply. So now we have to look into a new innovation system called urban farming. So to support the food security during crisis. I put the question, resilience in crisis, the Saudi approach to food security during global challenges. 60% they strongly agree we did a good job. 32% they agree. Where is social agriculture to be used? It could be used worldwide. There is no country doesn't need to apply social agriculture. But especially important in arid and semi-arid region, especially in the Arab world. We have to realize, we have to know, we have to face reality. The majority of the Arab countries do suffer to get their basic human need. So we have to address those issues. In those areas, we can use local knowledge, traditional practice, and innovative technology to restore damaged land, improve soil health, and increase agriculture productivity. The effective development program supporting social agriculture projects in the Arab country villages throughout collaboration among government, private company, and academia to achieve sustainability. I'll give you an example. I promote, I'll take Lebanon as an example. In Lebanon, there is 1,200 villages. My argument, if we give $30,000 per village with the cooperation of American University, the local government, and the local peoples, then we could improve at least 200 individuals, 200 people per village. That will give a lot of improvement for Lebanon. It's very important, especially as a program for rebuilding countries after war. And you know, we have a lot of wars going on. This teamwork among different aspects or different sectors is the most effective way to reach sustainability. This model can be replicated to other countries. How to use social agriculture? As I said, a successful implementation social agriculture is a multi-dimension approach. Is needed to start with a triple helix model. What is a triple helix model of innovation? It's involved collaboration among government bodies, private organization, and academia institution, engaging local communities and stakeholders in the decision-making process of crucial education and capacity building program that empower the individual and the group. Additionally, forming a partnership between government, NGOs, and private sector can provide resources and experience massive. Not a single country or a single identity can do that. I'll give you an example from Saudi Arabia. Alhamdulillah إنه السعودية سوت هذا البرنامج وطبقته. Empowering communities through social agriculture, Saudi social agriculture provided a significant benefit to many groups. I'll give you an example. Saudi Arabia have launched an initiative in Jizan. It illustrates this impact. They make it a contract with IFAD, an international organization. And by the way, Saudi Arabia was one of the main instruments who have created the IFAD, led by $4 million. Yeah, you might think $4 million is a very small amount. It's not. If you use it effectively, it's a lot of money. The $4 million project to establish 60 model mango farm and 10 models of coffee farms. This initiative aimed to help 30,000 farmers by introducing advanced agriculture technology using recycled water and encouraging innovative production method. Saudi Arabia commitment, as I said, I always believe social agriculture is a vital to be used as the donation programs on their donation. Alhamdulillah, now they implemented it. Saudi Arabia have recently given an example of a commitment of $10 million with King Salman Center for Relief and the Higher Commissions of Lebanon, $10 million. Yeah, you could say $10 million is a small amount. It's not, it's a huge amount. We used to give billions of dollars and the result was zero. Now with the $10 million, we have achieved wonder. If you use it, if you manage it, if you monitor it, it's highly effective. This highlights the importance of the kingdom dedication to humanitarian cause and sustainable agriculture practices. One of the worst things we used to do before, we give donation, we don't mention it, we don't talk about it. And now, one of the best things Saudi Arabia have done, now you could go into the King Salman Relief and you could find every country how much Saudi Arabia have donated to it and all the projects. Before I used to throw this argument. If you go to Saudi embassy, I repeat, if you go to Saudi embassy into any of these countries and you ask them to name 3 projects Saudi Arabia have financed in those countries, I assure you, I bet you, that they will not know. Now, it is available online. Everybody could read about it, and they could see how much we have helped. I put a question for collaborative framework for sustainable agriculture, which is the triple helix. Nearly 70%, they strongly agree, and about 20% they agree. So almost 90%. That is the triple helix, which is government, academia, and private sector. They work together. Of course, we have challenges. How do you come with those challenges? If you don't have challenges, you have a problem. If everything you think is going right, then you're on the wrong side of it. You have to, if you don't face difficulties, you know you're in the wrong direction. You could sit home, do nothing, and you're still gonna have a problem. So, successful people always face challenges. What are those challenges? Number 1, economic challenge. Instability often limit investment in agriculture project. Water scarcity. Water scarcity is in every country. I don't know a single country in this earth, maybe Argentina as an exception, didn't have a problem with the water. Furthermore, climate change. It impacts the rural area a lot more than the urban area. Why? Because money goes to urban area, because the urban people, they have the authorities, they have the voting, they have the TV, they have the mouth to talk. People in the rural area, they don't have that power. That's why they're always the least being developed and the most being affected by crisis. Finally, many small farmers struggle to access market for their product, which limit their ability to succeed in competitive environment. I was invited in Sri Lanka at the Commonwealth, and there was a 52 or a 54 president, prime ministers in that meeting. and it was in Sri Lanka, 2013. And I put that argument, and I think it was the Vice President of Nigeria. He challenged me, and he said, I will do this, I'll do this. I said, you wouldn't even have time, because rural area, it's easy for you to build a bridge or a tunnel for $1 billion, but it's very hard for you to build a dirt road in the middle of Nigeria that costs $100,000. He made a pledge that when he go home, he will create a special department, have full access to him to visit those areas and fulfill their need. He did, by the way, made that commitment, and I know he succeeded. Collaborative action against climate change. The role of government, almost 50% of the people, they said it is important. Private sector, and then you could share, I will share with you this PowerPoint. You could find it at the website of the University of Arizona, and we will find other ways also that it will be available. And I'm sure it is available at the COP16. You could talk to our good organizer, and I'm sure they will make it available online. Let's talk about another project. Saudi Arabia have built the terrace, which is the RATL in Jizan, المدرجات. As I said, they have spent $4 million, and it affects 30,000 farmers. And we have looked at القهوة الخولانية. How many of you tasted الخولانية? هزيت راسك. It's a wonderful. I used to buy it in a big sack, and we pay a lot of money for it, and we lose about almost 20% only dirt, and we clean it. Now we could buy it from Jizan, and my God, it's beautiful. And I am a coffee drinker. The organic farming, how important it is. Nearly 56%, they strongly agree in the importance of the organic farming. Advancing social agriculture for sustainable impact. As I said, improve that we need to expand the existing program. We need to make a deal with the NGO. We need to get involved all stakeholders. اليد الواحدة ما تصفق. If we don't collaborate with everybody, there is no way we can succeed. We have to regenerative farming technique. We have to restore our ecosystem. The old system do work sometime, and we have to depend on it. The aiming, by aligning our effort and resources, we can develop resilience. Land governance through social agriculture for sustainable development. Social agriculture offers, in my opinion, a very strong solution to land degradation. It has many aspects for rural and urban. One aspect is social aspect of agriculture, goes beyond just market production. It is vital for support social reintegration and encouraging collaboration for sustainable future. It make farmer thrive. It make improve the business development. Ultimately, embracing social agriculture not only help combat land degradation, but also empower community, especially rural community. I will close my talk. Let us leverage the power of social agriculture to combat land degradation. By working together, we can create a sustainable future where our land thrives and our community prospers. For more information about myself, you can visit the website tfrasheed.org. And more about this subject, I have, can I borrow your book, the book, please? You could find this book. It's in Amazon and everywhere. It was released in 2023, and it's also available in Arabic by مركز دراسات الوحدة العربية. It's all available in Arabic and in English. Happy to receive your question.
Thank you very much. This is really insightful and interesting. We'll get back to it. But for the sake of time, Safi, now we're going to get to you to tell us something about the innovation you made in the Sahel that is actually helping a lot of farmers, women, young people actually improve production and productivity.
Okay, thank you, Mr. Mamadou. I'm Sani Lolado Shafi from Niger. I'm running a company called Ipren, which develops a solution for agriculture. Do you know that the phone you guys are using can be used to fight against desertification? Actually, the technology leads us to create the solution for the future of agriculture. Now, we are talking about artificial intelligence. Artificial intelligence adapt to agriculture, make it more easier to know the problem of agriculture, to adapt our land, and also to have solution for climate changing. We're talking about IoT, Internet of Things. Internet of Things is kind of using sensor and also connect to a device. It may be your phone that you are using or the computer. So in 2024, now, we are combining this technology to create the solution for the future for agriculture. In my company, we are not developing project, but we are developing solution for the future. We have one first project, we call it Smart O. We use artificial IoT solution to create irrigation, to fight against water scarcity. Like an example, if you are a farmer and you are having a phone, you can just use your phone. From your phone, you can know whether your crops are in need of water or not. And then you can pour or activate automatically from wherever you are. Like for example, I'm here, I can control my farm in my country. Simply using your phone. Like, you can also know what the crops need, like the nutrient that is missing. We use this technology to adopt our crops into our land. When talk about desertification, okay, we create another solution. We combine this technology, but in different way. Like we try to create an artificial intelligence based on the crops requirement. Then from these crops requirements, we go to the land, like desert where there's nothing grow there. There's water missing, there's nutrient missing on the desert. Like we're trying to, based on the crops need, we can know what we need to add to this land to make it productive. And how we are trying to create another life into the Sahara. Then from this, we tried this solution in Niger. We have around 400 farmers that are using this technology. And also this technology lead them to increase their livelihood, to reduce water wastage around more than 70% of water